Hi my dear students, welcome to one more amazing session from Infinity Learn. How are you? So welcome to this one-shot board set NEET Tech. A series we are going to discuss today's class about hydrocarbons in one shot. How are you all doing? Please confirm, can you all able to see me, can hear me? Just give me a thumbs up and fire emoji. So in that series we are going to discuss NCERT based total topics from the NCERT and the NEET discussion. So from December 1st to and May 3rd your deadline, and we are going to discuss all the topics that is there in the NEET syllabus, and we are going to give you the parallelly the CBSE as well as NEET preparation. How are you all doing? So ready? शुरुआत से. So when you are doing something you need to have a plan. So आज ये सेशन में हम चर्चा करने वाले हैं हाइड्रोकार्बन्स. So this is 11th standard topic. So this particular session is about nearly 3 hours. In this 3-hour session, I want to focus about more alkanes, alkenes and alkynes. So let's have a plan, and in that plan, how to just crack NEET questions. So total concept revision I am going to do for the hydrocarbons, and at the end we are going to have very good awesome NEET level questions. Ready for that? So those students who are online, please give me thumbs up and fire emoji. शुरुआत से. So the hydrocarbon chapter. The hydrocarbon is the basis of the total organic chapters from the 11th as well as in 12th. From the details about the hydrocarbons, you can start with haloalkanes and haloarenes, from their carbonyl compounds and alcohols, phenols, ethers and all. So we'll do that right from the beginning. Before going for the hydrocarbons, I just want to give you actual ये hydrocarbon का plan कैसा बनाना है. So students, here I just want to say hydrocarbon NEET weightage. So what is the importance of this particular chapter in your NEET examination? बच्चों, hydrocarbons from grade 11 organic chemistry, it carries generally it is 3 to 4% of the total weightage of the question paper, and sometimes 2 to 3 questions directly can be asked from the hydrocarbons. So you will be having just 12 marks from the NEET paper. So let's see how we can project with that. So important topics and frequently asked questions from the NEET. It is about alkanes, alkenes and alkynes. In the alkanes, you can see free radical substitution, halogenation reactions. Now we are going to discuss that, and combustion and pyrolysis and monochlorinated products, and also conformations of ethane is also very important. And we discussed these conformations in isomerism chapter. You can just go ahead with that. So students, you take a pen and paper and write along with me all the reactions and everything we are going to discuss. A single concept will not be missed. And also important topics from these alkenes. It focus on electrophilic addition reaction and also elimination reactions. And also you are going to see hydroboration oxidation, ozonolysis and stability of alkenes and combustion reactions. Heat of hydrogenation. Hi. Demish, some name I can't actually pronounce it. Okay, let's see. So this particular session is about 3 hours. Take a pen and paper, write along with us. And also isomerism, E and Z configuration is also very important. Cis and trans isomerism, and talking about alkynes. And in this alkynes, acidity of terminal alkynes is the one of the most important topic that you're going to see. And also electrophilic addition and also nucleophilic addition. Reactivities in the electrophilic addition and nucleophilic addition is very important. So to the sp hybridization. So this is about alkane, alkene and alkyne overall view, and we are going to see this is the plan. And where you are going to get a question based on this, NEET expected question types based on hydrocarbons. So in this NEET YouTube channel, we are going to give you the subject, advices and the plans and everything. So we are going to say product prediction. ये कौन सा reactant से कौन सा product बना सकते हैं, ये बनाने के तरीका कैसे होगा बेटा, and identification of major and minor products certain rules का हिसाब से. जब आप एडिशन रिएक्शन इस्तेमाल कर रहे हैं ना, मार्कोनिकॉफ रूल इस्तेमाल करो. एंड एलिमिनेशन का जो प्रोडक्ट है ना, सेड्सव रूल का हिसाब से आपका प्रोडक्ट देना पड़ता, राइट बेटा. एंड यू आर गोइंग टू सी आइसोमेरिज्म एंड स्टेबिलिटी ऑफ द इंटरमीडिएट्स एंड द प्रोडक्ट्स, एंड आल्सो रिएक्शन मैकेनिज्म एंड कॉन्सेप्ट बेस्ड, लाइक whenever rearrangement is there, आप mechanism बनाना है बनाना. Directly you need not have to write the product. And also before going for this, I want to give you, whenever you are preparing for any examination, it is important to know what topic you are doing and how you are doing, आप कैसे कर रहे हैं, and also where exactly you stand. What is your improvement areas, where is your point is weak, where is your point is strong. For that you need a very good assessment platform, InfinityLearn. We are going to give you a very good assessment system, that is NEET test series. This NEET test series is an ultimate key to NEET success beta. आज हम सेशन में चर्चा करने वाले हैं बोर्ड्स से नीट तक. Nandini Rai, hello, hi. So this NEET test series is prepared based on this latest NTA pattern, and it is prepared by NEET eminent faculties. And this particular test series is given real-time simulation for your NEET examination. Nandini, hi. Now, it is separately prepared for grade 11 बच्चों के लिए, grade 12 बच्चों के लिए, and repeaters को भी है. And in the description box link is available, and just click it and just pursue it, and if you are interested you can purchase it. And और एक चीज है, when you just purchase it, apply YouTube 30 off, ताकि आपको 30% automatic discount मिलेगा बेटा. So I don't want to give much introduction about anything. Directly I just want to discuss the concept hydrocarbons. So take a pen and paper everybody and write the important noteworthy points. आज सेशन में हम पूरा कॉन्सेप्ट हाइड्रोकार्बन्स का हिसाब से अब डिस्कस करने वाले, alkane, alkene, alkyne, and also I am going to give you certain tricks and tips, and make a note of this, and various examples I just want to discuss here, and at the end NEET PYQs will be discussed, and also some NEET projected questions will be discussed. Right, Nandini, hello. So those who are online, एक thumbs up and fire emoji. So हम बच्चों के लिए कुछ भला करने की कोशिश कर रहा हूँ, and these sessions are absolutely free of cost. You can simply sit at home and you can attend the sessions. We don't expect anything, just a like and share with your friends, or subscribe to InfinityLearn NEET YouTube channel. So talking about hydrocarbons. Hydrocarbons are the group of organic compounds which contain carbon and hydrogen, and these hydrocarbons are classified into saturated carbons and unsaturated and aromatic compounds. Hi Surya Pratap, Radhe Radhe, Betu it seems, right? And saturated carbon ka complete single bond, and unsaturated single bond means alkanes or cycloalkanes comes under this. You are going to have CnH2n plus 2, and alkenes carbon to carbon double bond, and alkynes carbon to carbon triple bond, and aromatic and benzene related compounds are called aromatic. Now in this scenario, we'll start alkanes and alkenes and alkynes. So in this 3-hour session, we will be having a couple of breaks as well. Okay, so let us be, I can guarantee you at the end of today's session, definitely you will be completing a confidence to have at least 12 marks from the NEET paper, right? Now let's talk about the alkanes. The general formula for the alkanes is CnH2n plus 2. And alkanes are also called paraffins. Para means less affinity, affins. So they have less chemical reagents. So little affinity towards many reagents, so they are said to be paraffins. That's the reason why you have a candle. The candle, it is unreactive unless you burn it. So you can say the candle is made up of paraffin wax. So let's see here. So preparation, directly I want to jump into the preparation better. So in this preparation, direct hydrogenation, catalytic hydrogenation of alkenes or alkynes. So you are going to get addition of H2 in the presence of a catalyst. So what are the catalysts we can use? Nickel you can use, platinum you can use, palladium you can use, rhodium also you can use better. You can also use rhodium and you can also use ruthenium, whatever. And reducing agent is hydrogen here. And you can generally use Raney's nickel. So Raney's nickel means is not a special nickel, this is a processed nickel. All nickel alloy is soaked in the sodium hydroxide. So that hydrogen gas is produced and adsorbed on the surface of the nickel. So that is stored in ethyl alcohol container. So whenever you want to use nickel and hydrogen, you can directly take Raney's nickel like that. So it is about catalytic hydrogenation. You have various catalysts. Alkene, when you add hydrogen, you are going to get alkane. Even alkyne, when you add nickel, platinum, palladium and hydrogen, you are going to get alkane. So anything you are going to get. So platinum, palladium catalyzes these reactions, surface catalyzed reactions at room temperature. But the relative high temperature and the pressure are required when you use nickel. So I want to say, whenever platinum and palladium is used, reaction can take place at room temperature. If you want to use nickel, the reaction requires little bit of pressure, little bit of temperature. So noteworthy points are also seen here, right? So you just take these points and make a note of this, bacho, right? So keep asking doubts. If you want to have this kind of doubts, if you want to have this kind of sessions, you need to go to a coaching center, pay thousands of rupees and you have to travel. But in this session, we are going to give you the best for free of cost. You all take this and get advantage of this. But those who are online, please like the session. And this reaction is completely syn addition. And this reaction is completely syn addition beta. So let's see. Substrate molecules, okay, preparation of alkyl from alkenes and alkanes. So surface catalyzed reactions. When these surface catalyzed reactions are taking place, it is supposed to be syn addition. What is the meaning of a syn addition? Addition of the species on the same side of the molecule is called a syn addition. Here I just want to say the substrate is adsorbed on the surface of the catalyst and hydrogenation takes place. So actually the syllabus surface chemistry is not there for the NEET examination, but the usage of the concept called adsorption is required in this concept, right? So moving ahead here, so catalytic hydrogenation of hydrogen is a syn addition. What is the meaning of a syn addition? So you have addition to the places of the parts of the adding reagent on the same side is called as a syn addition. So I don't want to confuse you, but you can take this is your cycloalkene, so cyclohexene. If you want to add a D2 in the presence of platinum, so the deuterium is going to be added on the same side. So this is what is called as deuteration and this is called a syn addition, same side. Are you getting or not? This is fundamental rule. So you may be asking a question based on this, is stereospecific reaction. What is stereospecific reaction? थोड़ा सा रुकना and मैं alkene में पढ़ा सकता हूँ मैं. So in this today's session alkene के बाद alkene आ सकते हैं, तभी आपको पता चलेगा. So you want to say this is your alkene. When you add X and Y, X and Y are added on the same side of the double bond is called as syn addition. समझ में आ रही है बेटा? एंटी एडिशन क्या होगा? ऑपोजिट साइड में होगा तो एंटी हो सकता. So there are near about 255 slides are there. Let me give you the total content of this hydrocarbon session में. So रुकना and you all enjoy today's class. I can guarantee you that, and 12 marks at the end of this session will be yours in your NEET examination. Sir, the notes PDF for the premium class hasn't been sent. What is that premium class? I don't know that. So how am I supposed to take the notes? Already know that the playlist is very confusing for me. Okay, so I'll talk to the operations team and they will help you. Is that Betu? Is that Betu? Yeah. So when you say Radhe Radhe, I can say, okay, I will talk to the team now. Okay. And talking about anti-addition, kya hoga? If addition is taking place in one side is called syn addition, in the opposite side it is called anti-addition. Okay, beta? So look at this, as anti-addition takes place in the parts of addition reagent on the opposite faces of the reactant is called anti-addition. Look at this, here it is going to be a carbon to carbon double bond. If you want to add X and Y is a reagent, X and Y are added in the opposite side. So that is called anti-addition. That is what is called anti-addition. My notes for all subjects are pending. I am very scared about how to do it. No worries, better. In the Telegram channel, you are going to get all the PDFs. All the PDFs. Right? Did you join the Telegram channel? Okay. Now let's talk about here preparation of alkane from alkenes and alkynes. So this is your cyclohexene, dimethyl cyclohexene. When you add hydrogen in the presence of platinum, you see the hydrogen is added in one side. It could be in the front side or it could be in the back side. Both are same. Meaning of these two structures is both are same. This is what is called as an anti-addition. This is what is called as an anti-addition. And you can also say the ease of reduction of this alkene decreases with the degree of substitution of the double bond. So it is all depends on the stability of alkenes. If the alkene is more stable, it is going to be less reactive in hydrogenation, and vice versa takes place. And it is a super concept to understand. So this is the way you need to understand the organic chemistry in such a way that you are talking about alkane preparation. Now you are talking about alkene hydrogenation in one shot, two birds. Fine? Yes, it can be done confidently like this. बच्चों, in the NEET examination, आपको question पकड़ना कैसे? So what we are doing here? NEET preparation. We are here, Dr. Suresh is helping you to prepare NEET examination. So NEET examination के questions कैसे बना सकते हैं इसका हिसाब से. बच्चों, if this is an alkene, which alkene is going to be more reactive? Which double bond? A double bond or B double bond? So I have joined, but the notes PDF for this classes which for the boards need not coming for the Telegram. I'm very worried. How can I should make a notes? Hi Sharma, hi. So I want the answer from your side. A is greater than B or B is greater than A or A is equal to B. Tell some answer. So Beto, don't worry, I will take care of your notes. I will take care of the notes. Okay, today only, right now I am going to help. Okay, so आंसर दे दीजिए, आंसर देना. एंड नीट एग्जामिनेशन का ये क्वेश्चन कैसा आ सकता, which is more reactive, A is more reactive than B or B is more reactive than A? Sharma, Nandini Rai, Betu, come on. I want to say this. The one which is more stabilized by hyperconjugation, actually double bond means alkene. Alkene stability is governed by hyperconjugation. जिस डबल बॉन्ड का हाइपर कॉन्जुगेशन ज़्यादा होगा वो स्टेबिलिटी ज़्यादा होगा, रिएक्टिविटी कम होगा. बेटा, कैन यू प्लीज री अपलोड द सब्जेक्ट वाइज सिलेबस बेस्ड प्लेलिस्ट? Okay, I will see how best I can do. Okay, you just attend from one-shot series, so I try to regularize it. Okay, previously what happened I don't know. Talking about here, I want to say B is more reactive than A. So this is how NEET examination questions will be asked. Dear children, this is very important. NEET examination questions ऐसे आ सकता. B is greater than A because this is more stable due to resonance than this. So stability and reactivity. Reactivity and stability inversely proportional. Carbon A is sp3 hybridized, but carbon no. This is sp2 है, दोनों भी sp2 है बेटा. This is also sp2 and this is also sp2. समझ में आ रहा है क्या बेटा? Right? No worries. Right. Now talking about ease of reduction. B is greater than A. Your answer is correct. And alkynes are more reactive than alkenes towards catalytic hydrogenation as they are less hindered. So that I want to say here, so from alkyl halides by reduction reagent you use zinc and dilute HCl. Alkyl halides, when it is treated with zinc and HCl, you are going to get alkane. Reduction takes place. Okay. Alkyl halides, zinc and HCl, you are going to get an alkane. Now you can use not only zinc and HCl. What are the reagents that can be used? You can use zinc and acetic acid, sodium in ethyl alcohol, okay, zinc and HCl, HI in red phosphorus. So like this, very important reagents you can use. You can use lithium aluminum hydride in the presence of an acidic medium. बच्चों, जब आप लिथियम एल्यूमिनियम हाइड्राइड इस्तेमाल करना चाहता हूं, एसिडिक मीडियम में इस्तेमाल करना है. एंड whenever you are going to get sodium hydroxide, sodium borohydride, you have to use basic medium. Or also you can use a triphenyl tin hydride. So in the NCERT one reagent could be given and you can see these many reagents that can be used. Definitely I'll make it to help you. Don't worry, please follow the class. Bachcho, so take a pen and paper, write all these reagents, bachcho. Any doubt? If you have any doubts, use this chat box generously and ask us. We are delighted to give you answers for any type of your questions. Thank you very much. YKY, thank you very much for your compliments. December itself, definitely, if you want, I can send you the ordinary PDF as well. In the Telegram channel, you can connect with me. Bacho, I'll take your name, beta. YKY, hyphen Y1P. Array, you give your original name, then I can take your name, right? Okay, so this is about alkyl halide. Now you see, zinc actually iska mechanism kya hoga na? You see, zinc and dilute HCl. If you use zinc and dilute HCl, zinc is going to be electropositive metal, gives 2 electrons. And these 2 electrons are taken by the Rx to give rise R minus and X plus. And this R minus is going to poke this hydrogen from the HCl to give rise alkane. Okay? Right? So, mechanism you did it now, sir. Is it required to have a mechanism all the way? Absolutely not. If required, I am going to tell you. If required, you can take this mechanism, otherwise you don't take the mechanism. Thank you very much, and I want your actual name, beta. YKV. YKY. Okay, I want your actual name. I am more comfortable to call you with your name. Okay, come on. Let us say alkyl fluorides cannot be reduced using zinc and HCl as carbon to fluorine bond is very stronger. Arey beta, NEET examination, you have multiple choice questions. In that, assertion reasoning is also very important. So, alkyl fluorides cannot be reduced by zinc and HCl. Assertion, reason is here. So, assertion and reason are correct, and reason is the correct explanation of assertion. हिंदी है, हिंदी में जा सकते हैं ना. आपका नाम बताओ पहले, आपका नाम बताओ पहले. सो जो नीट एग्जामिनेशन में assertion, reasoning, statement 1, statement 2 का क्वेश्चंस प्रोमिनेंट है. ओके, इफ यू वांट टू आंसर दिस टाइप ऑफ क्वेश्चन, कॉन्सेप्ट में आपको बहुत बेहतरीन नॉलेज रहना पड़ता है, कमेंट भी रहना पड़ता है बेटा. ओके, ठीक है. एंड लेट्स टॉक अबाउट द प्रिपरेशन ऑफ alkane फ्रॉम alkyl halide. और क्या कर सकते हैं बेटा? रिडक्शन कर सकते हैं, एंड बाय रिडक्शन में आप वुर्ज रिएक्शन भी कर सकते हैं. यस, दैट इज अ कपलिंग रिएक्शन. ये कपलिंग रिएक्शन में क्या होगा देखो. सो द रिएजेंट यूज्ड इज सोडियम इन ड्राई ईथर बेटा. Sodium in dry ether. So, what happened when alkyl halide react with sodium metal in the presence of dry ether? It is going to give you NaX. So, चाहे इसका alkyl chloride हो सकता है, सोडियम क्लोराइड बनेगा, एंड ये alkyl ग्रुप जो है ना, ये दोनों कपल करके हायर alkanes can be prepared. ठीक है? It is a coupling reaction. Therefore, methane cannot be prepared by this method. तो क्या, फिर भी ये assertion reasoning reaction का है. देखो, you can see when sodium, you see the mechanism, you have the mechanism, and ionic mechanism इस्तेमाल कर सकता है और radical mechanism भी कर सकता है. Now, for Wurtz reaction, free radical mechanism is more accepted mechanism बेटा. ओके, आपका नाम बोलना है यार बैठने. So sodium loses the electron because sodium being a highly electropositive element, it loses the electron. So that the electron is trapped by this Rx, so that X minus दे दिया इसको. You can see this. So X minus R free radical बना, एंड जो R free radical दोनों मिलके आपका higher alkane बना है. And this is a so complicated system, so side products can also be given, disproportionated products can be given, minor products can be given, and there are some noteworthy points I want to give you for the preparation of alkane by Wurtz reaction. So when you talk about this Wurtz reaction, you have alkyl halide knowledge भी रहना है. So the reactivities, Wurtz reaction here, sodium reacts rigorously with water because it is highly electropositive. You know, sodium explosively reacts with water, so that you need to use dry ether. Usage of dry ether is important. Example, diethyl ether, C2H5O, C2H5. अचानक आपका THF दिखाना चाहता हूं. What is that? टेट्रा अभी मध्य प्रदेश या ओके. सोनाली, अनुज, दिस इज टेट्राहाइड्रोफ्यूरेन. इसका स्ट्रक्चर ऐसे आपको दिखाना चाहता हूं, ऐसे आगा. टेट्राहाइड्रोफ्यूरेन इज ए साइक्लिक ईथर. in the notes, okay, definitely. बच्चों, in the description link will be given. Telegram channel में आप join करो. So after this session, the total session notes will be given in the PDF format. ठीक है बेटा? या आज साबूदाना. ओके, सो सुबह से मैं कुछ खाए नहीं. I'll have lunch directly after this session beta. So आप चार्ट बॉक्स में लगे रहो. And you can see methyl chloride react with sodium to gives rise ethane, because this and this is coupled to gives rise ethane, right? And also dry ether is very, very important. If dry ether is not there, you are not going to get free radicals. Sodium is going to react with this moisture. ठीक है बेटा? And also methyl chloride is going to give various products beta. How it is going to give this? Reactivity, once you got this methyl chloride, okay, and ethyl chloride. So what will happen? You are going to get methyl and methyl free radical. What are the free radicals that are going to generate? CH3, and you are going to get CH3, CH2 dot. Now methyl free radical दोनों मिलके आपका ईथेन बन गया. methyl free radical, ethyl free radical मिलके प्रोपेन बन गया. ethyl free radical मिलके आपका ब्यूटेन बन गया. But mixture of alkanes are produced. You know, this is actually not acceptable, because alkanes do have the nearly the same boiling points. So it is very difficult to separate the mixture of alkanes. That is the reason why alkanes, odd number carbon alkanes, a mixture of alkanes cannot be used for this Wurtz reaction. So I want to say, as a mixture of products are formed, yield any product is not significant, therefore is not preferable to us. Differentiate alkyl halides. Okay, this is a very important noteworthy points. Boiling points are so close so that you cannot separate them. Sonali, fine? Any doubt? So moving ahead here. And in this Wurtz reaction, alkanes with odd number and even number carbons are produced, and a mixture of products are formed in this reaction. So it is very difficult to separate this mixture. Therefore, Wurtz reaction is generally used in the preparation of higher alkane containing even number. Odd number का नहीं इस्तेमाल करना है. समझ में रहे क्या बेटा? Clear? Any doubt बच्चों? That's good, wonderful. And talking about decarboxylation, और एक चीज है, reactivity of this Wurtz reaction. Alkyl iodide is more reactive than alkyl bromide, is more reactive than alkyl chloride, is more reactive than alkyl fluoride. You know, alkyl fluoride will not be reacted. That's very important. And talking about decarboxylation. So decarboxylation by soda lime. Arey beta, what is decarboxylation? Somebody please help me. Somebody help me. What is decarboxylation? Anuj, Beto, YKY. So what is the meaning of deforestation? अरे बेटा, deforestation होता है cut the tree. Decarboxylation होता है cut the carboxylic group. Dehalogenation होता है cut the halogen. Dehydrogenation होता है cut the hydrogen. Dehydrohalogenation होता है cut the halogen as well as hydrogen together. Right? So like that you can do the wonders in the chemistry. Decarboxylation, reaction with carboxylic acid loses CO2, carboxylic group is removed as CO2. So what is the soda line? You see, reagent sodium hydroxide, caustic soda and calcium oxide quicklime, it is the mixture, you call it as a soda lime. ठीक है बेटा? And you see this is RCOONA. You just see the color of the atoms also. 1 carbon, 2 oxygens are removed as carbonate, and the hydrogen of the sodium hydroxide is given to here, and you are going to get alkane. उसमें चाहे इसका n नंबर कार्बन होगा, जो अल्केन आपका फॉर्म कर रहे हैं ना, n-1 नंबर ऑफ कार्बन्स होगा. सो ये जो मेथड है ना, डिसेंडिंग कन्वर्शन करने के लिए आप इस्तेमाल कर सकता हूं. Decarboxylation is the process where the carboxyl group is replaced by hydrogen atom, effectively by removing one carbon atom from the main carbon chain. Okay, Beto has given an excellent answer for this. Congratulations. And I like the way you are following the class. Thank you very much, Betty. And you see, this decarboxylation gives you the 1 number carbon less. Okay, itna din ke khana. Okay, focus. Let us focus on the academic charting. Okay, academic charting is very important, beta. अगर आपको डाउट है ना तो बेतु, I really appreciate your efforts. अगर कुछ डाउट है ना तो पूछना जल्दी. I want you to give the mechanism as well. Those who are online, please like the session. Please like the session. And I want to see, this is the sodium salt of carboxylic acid, and this is the sodium hydroxide ka OH minus hai na, it is going to attack on the nucleophilic site, so that you are going to get a tetrahedral intermediate which is prompting to generate alkyl carbanion. This is the rate determining step, and it is a slow step. And carbanion stability का हिसाब से आपको प्रोडक्ट देना पड़ता है. आज चिन्ह स्वामी है. Now this carbanion is going to abstract the proton to give rise NaHCO3 से एक प्रोटॉन पकड़ के alkane बन गया. So the reactivity towards the decarboxylation is directly proportional to the stability of carbanion. That is very very important. जो carboxylic acid stable carbanion दे सकता है, वो decarboxylation जल्दी कर सकता. So NEET examination में आपको ये जैसे क्वेश्चंस आने का संभावना है. So which of the following carboxylic acid is decarboxylated more easily? So rate of decarboxylation is directly proportional to the stability of carbanion. Don't worry, beta. I'm going to give Surya Pratap. I'm going to give you the notes in the Telegram channel. Please don't worry, I'll take care of it. Okay. And reactivity, rate of decarboxylation. Is directly proportional to, otherwise acidic strength you can say. हर कार्बोक्सिलिक एसिड का एसिडिक स्ट्रेंथ होता है ना, एसिडिक स्ट्रेंथ के हिसाब से आप दे सकते हैं. एंड आल्सो यस, थैंक यू वेरी मच सूर्य प्रताप. एंड आल्सो बीटा कीटो कार्बोक्सिलिक एसिड्स आर इजीली डिहाइड्रेटेड. बीटा कीटो एंड दिस इज अ नोटवर्थी पॉइंट. नीट एग्जामिनेशन में ये पॉइंट का हिसाब से क्वेश्चन आने का संभावना है बेटा. वेरी 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 इंपॉर्टेंट. टेक केयर ऑफ दिस. ओके अनुज. सो लेट्स सी हियर Many points. Alkane produced by this method has contain one carbon atom, descending conversion हो सकता है. Rate of decarboxylation is directly proportional to the stability of carbon ion. These are the noteworthy points I have given. If you have any doubts, please let me know. Those who are online, please like the session. I just want to so moving ahead, Kolbe's electrolysis method. Kolbe was a scientist. He did electrolysis for this potassium salt or sodium salt of carboxylic acid. So an aqueous solution of sodium salt or potassium salt of carboxylic acid on electrolysis, it gives a corresponding alkanes. So even number of corresponding alkanes. Again, methane cannot be prepared by this method. Okay, odd number कार्बन्स वाला भी नहीं कर सकते, सिर्फ इवन नंबर वाले के कर सकते हैं. And you see, sodium salt of a carboxylic acid, sodium salt of a carboxylic acid, it is electrolyzed, it gives rise higher alkanes. Now looks little confused. You don't confuse, I am going to give you in my own way. RCOONA, RCOONA, it is electrolyzed in the presence of water, so that H plus OH minus you can say. So what will happen? H2 gas will be formed at cathode, and sodium hydroxide will be formed here, and carbon dioxide will be formed at anode, and दोनों मिलके ए alkane मिल गया. एनोड पर कौन सा प्रोडक्ट आ रहे हैं? Alkane and carbon dioxide is coming. The products formed at cathode is going to be hydrogen. See the mechanism. At anode oxidation takes place. Oxidation means loss of electron, gain of electron is reduction. Carboxylate ions losses electron, gives rise to free radicals. These free radicals carbon dioxide छोड़ के और alkyl free radicals, you got it. This alkyl free radicals दोनों मिलके आपका alkane मिलेगा. And also this is your major beta, this is your major, आपका minor product भी आ सकता. Understand? And it's a marathon session, and we are discussing so many things in the class. Please take a note, stay tuned, be patient. Okay, time लगेगा. NEET and medical seat मुफ्त में नहीं आएगा बेटा, थोड़ा सा मेहनत करना. मैं इन्फिनिटी लेन यूट्यूब चैनल से आपको मदद देना चाहता हूँ आपको NEET एग्जामिनेशन में भला करने के लिए. ठीक है बेटा. अगर आप रिडक्शन में कैथोड में रिडक्शन होना है, what is that? Nitrization. Omkar Shavan, nitrization we'll discuss in the next. Now let us talk about alkanes and alkenes here, right? Okay, here H2O takes an electron, gives rise OH minus and hydrogen free radical, and this hydrogen free radical मिलके hydrogen gas बनेगा, reduction होगा. And also you see, as the reaction proceeds, pH of the solution increases. NEET examination. Okay, ये point में NEET examination, क्योंकि you see बेटा, देखो ये product में we are generating sodium hydroxide as a product. In the product side, sodium hydroxide is produced, so that pH increases during the reaction. Every point I am discussing, please take use of this point. So as reaction proceeds, the pH of the reaction increases. NEET examination catchy point. You will be trapped here. Yes, of course. Omkar, you can. It can definitely help you, because we are integrating multiple concepts better. We are integrating all the concepts. Okay. And also On using two different types of sodium or potassium salt of acids, mixture of three alkanes are obtained. That is also a noteworthy point. That is also a noteworthy point. Those who are online, please like the session. Omkar Chavan, please like the session. I want you to please like the session. If you press the like button, I can directly visualize that the number of likes is increasing, and please mention anything you want in the comment box as well. Okay, I'll very helpful to you. I can give you the help at any extent. Omkar, right. Now let's see here physical properties of alkanes. So we can have physical state, color, order, solubility, boiling point. And boiling point का हिसाब से एक क्वेश्चन आ सकता. Definitely. Like it. Thank you very much. You see here at two physical states at 298 Kelvin at room temperature beta, you can see as the number of carbons increases, alkane, its boiling point increases. You see carbon 1 to 4 are gases, methane, ethane, propane, butane are gases. And you see C5 to C17 are liquids, all petrol, diesel, kerosene, everything comes under this category. And C18 का ऊपर जो है ना, they are coming to the solids. अरे बेटा, I am your teacher, okay? Right. Right. Now moving ahead, alkanes are colorless, odorless. Alkanes are colorless and odorless. And also they are soluble in the organic solvents. They are not soluble in the aqueous polar solvents. Okay. Whenever you are pronouncing your teacher, you say your teacher name with sir or ma'am, right? That's a good point, right? Simply don't say your name, your teacher, right? That's not good practice. So let's see. I want to say here boiling point of an alkane here. Boiling point is directly proportional to van der Waals forces, is directly proportional to the molecular mass. As you see, as number of carbon atoms increases, you are going to increase the molecular mass. As the molecular mass increases, molecular size also increases and van der Waals forces increases. बहुत मिस किया आपको, क्यों? कोई प्रॉब्लम नहीं. I always be with you till your examination. ठीक है बेटा? And Anush, like button मारना है, like button मारना. You are missing, but you didn't like it. Okay. Now you see methane boiling point, ethane, propane, as number of carbon atoms increases, boiling point increases. Okay. And also for the same molar mass, for isomeric alkanes, boiling point inversely proportional to the branching. So as branching increases, बच्चों, as branching increases, overall surface area decreases. इसमें reasoning भी आ सकता. NEET examination, जय कुमार, hello. NEET examination में आपका assertion reasoning भी होना चाहिए. Please like the session. Hi. So as branching increases, overall surface area decreases. Today I eat chicken. No. Academic discussion only should go in the class. Thank you very much, Jai Kumar. As surface area decreases, intermolecular attraction forces decreases. ताकि इसका boiling point भी कम होना चाहिए. ठीक है बेटा? That's good. Very nice. And that's why I can say here, C5H12, you are going to have N-pentane, 2-methylbutane, 2,2-dimethylpropane. Okay, Jai Kumar, you please ask that out. So the boiling point is going to be like this. So normal pentane, this is isopentane, this is your neopentane. This is your neopentane, right? Yeah, Omkar Chavan, let me speed up. Definitely. Jai Kumar, you have a doubt, right? So chemical properties, alkenes are inert to most of the reagents under normal conditions. Sir, please don't forget, do it quickly so that I am finishing my notes soon, please. Surya Pratap, definitely. And alkanes, whenever, I am going to tell you one thing, whenever alkane comes into the any reaction, nothing you can do except free radical halogenation. Definitely, Anuj, definitely. Now you can see, but under certain conditions they can react. What are the conditions? Here, substitution reaction, combustion, controlled oxidation, isomerization, aromatization, reaction with steam and pyrolysis. These are the list of the reactions that we can have with alkane. Let me quickly speed up. If anybody want little bit slow version of this teaching, you please let me know so that I can slow down. Till then, I am going to accelerate this. Take a thumbs up and fire emoji, come on. So let's discuss about, now let us talk about free radical halogenation. In the free radical halogenation, when one more hydrogen atom is, one hydrogen atom from the alkane is replaced by an halogen atom, this is called free radical halogenation. And this halogenation is taking place, example you can say methane, it is treated with chlorine in the presence of UV light, it is going to give methyl chloride. Okay, in this methyl chloride, and it is going to be a chain reaction, it goes like this. You got methane, methyl chloride, dichloromethane, trichloromethane, carbon tetrachloride. You can't stop this reaction. This reaction is so explosive reaction. So in this Jai Kumar, so I am talking English now, it is not Tamil, right? Okay, let's talk about the mechanism of halogenation. Whenever you have the free radical mechanism, you need to have three steps: initiation and propagation and termination. So what is these three steps? Let me tell you. So in this initiation, you are going to generate a free radical, and that free radical has to attack the reagent and the reactant to give rise further product to gives, and termination में जो free radicals बचा हुआ ना वो मुलाकात करके ये terminate करना है. Okay, so what is the Nessler's reagent K2HgI4? Let's see the each and every step: initiation, propagation and termination. And you can see homolytic cleavage. First homolysis क्या होगा? Whenever this bond pair of electron is exactly broken to half, you are going to get free radicals. And this free radical, CC bond is weaker than CCl. Cl bond is weaker than carbon to carbon bond beta. So CH bonds also. Hence the easier to break the chlorine bonds. That is important. ताकि इसका homolysis cleavage chlorine में हो सकता, right? And so that C free radical, chlorine free radical is going to abstract the hydrogen of the methane by homolytic cleavage. So that what happens? HCl banega and methyl free radical is generated. Voice is coming barely low. Okay, let me change the headphone after break. Okay, and this methyl free radical is going to abstract one more chlorine from the chlorine. So this is always homolysis only takes place, so that methyl free radical is going to talk about the Cl dot to gives rise methyl chloride, and again chlorine free radical is generated. So this is the elongate propagation step, and you can go ahead with the termination as well. In the propagation, step 1 and 2 is continuously proceeded, so that you are going to say methyl chloride dichloromethane, trichloromethane, and carbon tetrachloride. So at the end what happened, it has to be, so you see the reaction is going to be repeated several times as long as either chlorine is consumed or methane is consumed. ठीक है बेटा? Live from Coimbatore, here live from Hyderabad. Okay, let's talk about this termination. क्या होगा? Other steps are also possible which generate the multi-halogenated products. That's what I want to say. Right, beta? Now, moving ahead, termination में coupling of any leftover free radicals joined together to gives a neutral product. Like several pairings are possible for the radical coupling in the termination step. So, what are these proceedings? This chlorine and chlorine combine to gives rise chlorine molecule फिर भी form कर सकता है. And methyl free radical, in a methyl free radical you are going to get ethane. This is a very important point. Methyl and the chloride and gives rise methyl chloride. So during the chlorination of methane, little bit of traces of ethane is formed. Assertion and reasoning NEET examination. So why ethane is formed? Because of the termination reaction. समझ में आ रहा है क्या बेटा? So based on this you will be having a monochlorinated product का questions भी आ सकता है NEET examination में. So पढ़ाई करो, मस्ती करो, फोकस करो and NEET examination में सीट निकालने की कोशिश करो. ठीक है? Always my services will be always with you, and Infinity Learn NEET YouTube channel is going to give the best out of this. Okay, definitely we can do the best. Okay, let's see some more important things, bachcho. Some more important things. Now moving ahead, inhibitors in the termination free radical reaction. A substance slow down the or stop the reaction is known as inhibitor. All the reactive any alkyl free radicals consumed, so reaction stops at the period of time. So you can add Jai Kumar. I don't know Tamil, Jai Kumar. I know only English and Hindi. ठीक है? Enjoy life eating idli. Okay. So Tamil में नहीं कर सकता बेटा. Okay. Tamil तेरे माँ. Okay. नहीं एपड़े रिके. Okay. Inhibitors. You see, oxygen, traces of oxygen is important to inhibit these reactions. ताकि इसका free radicals are generated. Free radicals are generated. Fine, Jai Kumar. Right. So you can say the rate of reaction of alkanes with halogens. Fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. So iodination is a reversible process. So if you want to use iodine, you need an oxidizing agent like HNO3, HiO3. Right? And fluorine is super explosive, so that whenever you want to use the fluorine, it is not advised, so we don't practice this. So iodine is very slow reaction, so it is carried out by HiO3 and HNO3. So fluorine is explosive and so violent, so it is not controllable, so we don't practice it as well. ठीक है बेटा? Clear? Now moving ahead, iodination of alkanes. So we are learning all those things. एक घंटे से कर रहा हूँ alkanes. ठीक है बेटा? alkenes भी करना, alkynes भी करना आज एक ही शॉट में. So मेरा आवाज कम आ रहा है ना, थोड़ा सा Is my voice is audible बेटा? Is my voice audible? मेरा आवाज सुनाई दे रहा है क्या? Come on, give me a thumbs up. Give me a thumbs up. Check your internet connection. My sound is okay. Iodination. When methane is treated with iodine to gives rise methyl iodine HI. So this reaction is reversible because this is very slow in reaction. Whenever the reaction is slow, it could be reversible. So to avoid that, you need to use HiO3. So that HiO3 is going to react with HI, so that you are going to get iodine and water. So that you are removing HI, so that what happened, reaction is going to favor more in the forward direction. So this is NEET examination and assertion reasoning type question, and also in the JEE, in the CBSE also you will be having a descriptive type 2 marks question based on this. So आज हम सेशन का जो कैप्शन है ना, so CBSE से NEET तक अच्छा कॉन्सेप्ट आपको देना है. So this is a very important assertion reasoning type questions, you can going to get it. Okay beta. Now moving ahead, rate of replacement of hydrogen. ये free radical halogenation में क्या करना, you are going to replace one hydrogen with one chlorine. So the reactivity of the halogens, fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. But in the case of hydrogen replacement, tertiary hydrogen is more reactive than secondary, is more reactive than primary. Okay, so the order one-shot session had been happening earlier and the syllabus would have been completed by now. There wouldn't be any confusion in the playlist. No worries, syllabus will be completed with all topics from the NEET examination will be completed. ठीक है madam? And you see, tertiary hydrogen is more reactive than secondary, is more reactive than primary, than methyl. Rate of halogenation is directly proportional to stability of the intermediate. What is the intermediate? Carbon free radical. So it follows this order, and there no voice. So can you all hear my voice? Can you all hear my voice? Jai Kumar, can you hear my voice? Can you all hear my voice? Bacho? Now moving ahead. So remember one thing, very important thing I want to say. This is not preferred way of producing alkyl halide from alkanes, as this reaction you can't stop it. Multiple products are formed resulting low yield. This is very important point. And also the process of heating a substance in the presence of sufficient air or oxygen is called combustion. Alkanes undergo combustion and pyrolysis and kind of oxidation. And you see, alkanes are completely oxidized to CO2 and H2O. Therefore, we use alkanes as a fuels. And you see, CnH2n plus 2 gives rise Cn plus 1 by 2 oxygen gives rise n number of CO2 plus n plus 1 number of H2O, and heat is generated. So this particular equation that can help you to solve the questions from ideometry and some kind of stoichiometry reactions as well. And also you see here, for any hydrocarbon you can say large amount of heat is released during the combustion, so that alkanes are used as a fuels. It is extremely exothermic reaction. That's the reason kerosene, petrol, diesel, aviation fluid, all these done in this way. And heat of combustion, you see the heat released when 1 mole of the substance is subjected for combustion is called as heat of combustion. You know, thermodynamics के हिसाब से heat of combustion is directly proportional to number of carbon atoms. You know me personally, congratulations. Okay, example C3H8 is greater than C2H6 is greater than CH4. ठीक है? And also moving ahead, heat of combustion is inversely proportional to branching of alkane, for molecular mass is same for isomeric alkanes. So you can see this is pentane, isopentane, neopentane. As branching increases, heat of combustion decreases. दिस इज वेरी वेरी इंपॉर्टेंट, नीट एग्जामिनेशन में ये लॉजिक का हिसाब से एक क्वेश्चन आ सकता है, ठीक है बेटा। एंड ऑल्सो बच्चों heat of combustion per CH2 group is inversely proportional to the size of the ring in the case of cycloalkanes, okay. And you see cyclopropane is less stable due to more more angle strain than cyclobutane, than cyclopentane and cyclohexane. In this case you can say, according to Bayer's strain theory, 6-membered ring is extremely stable, so that always whenever you go ahead with the stability of the carbocation in the ring expansion, 6-membered ring is stable, so the process goes towards 6-membered ring. 3-membered ring is extremely unstable, okay. 5-membered ring is okay, it is stable, and 6-membered ring is extremely stable, and even 7-membered ring is not stable, okay. And 6-membered ring of the cyclohexane can exist in 2 forms, and that is cyclohexane, it can exist in chair form as well as a boat form. Which form is more stable beta? Mention in the chart box. Stability, chair form is going to be more stable as compared to the boat form. Are you getting or not? Clear? Now talking about incomplete combustion. So combustion in the absence of sufficient amount of air is called incomplete combustion. So methane is combusted incompletely, gives us carbon plus H2O. So this is the carbon black is formed. You know, this carbon black is used in printer ink. That's very very important beta. This is very important. So, and you see here controlled oxidation. So this is important for NEET as well as CBSE textbook may be there. We have to follow this. आपका डाउट क्या? अरे मध्य प्रदेश इडली and these things are not considered as your doubts. Anything related to corresponding topic you just tell me, okay. Now alkanes on heating regulated supply of oxygen or any catalyst, you have various products that can be formed, that is called controlled oxidation beta. So we'll see the CH4 can combine with oxygen by using a various catalyst. If you use the copper and 100 ATM, you are going to get methyl alcohol. In the presence of molybdenum oxide, you are going to get formaldehyde. Ethane, manganese acetate, acetic acid. So the reactant is same, but the product is different if the catalyst is changed. Sometimes catalyst has ability to select what product to be given. That is called selectivity of the catalyst. Okay, Re Coimbatore, Madhya Pradesh, काम नहीं चलेगा बेटा. Please follow this session. Okay. Now I want to complete this alkane and let us have 5 minutes break. And you see, बच्चों, this is the reaction and these are the various products. And direct, I can say NEET examination, the direct products पकड़ के ये catalyst कौन सा आ सकते हैं, that's very important. Because NEET examination focus on the NCERT, अगर NCERT में होगा तो ये NEET examination में आ सकता है. जय कुमार. And you see oxidation of alkanes, generally alkanes resistance for oxidation, but tertiary hydrogen of the alkane can be oxidized if you use any strong oxidizing agents are used, like KMnO4. Tertiary hydrogen is oxidized to gives tertiary butyl alcohol. So yeah, so this is, you can say CH3 and CH3 and CH3 and hydrogen, and it is going to give rise neopentane, gives rise tertiary it is going to give, so tertiary butane, and it gives rise to tertiary butyl alcohol. It is a strong oxidizing agent. Okay, this is very important reaction. This is very important reaction. Strong good oxidizing agent, powerful oxidizing agent. Okay, now bacho, isomerization of n-alkanes, normal alkanes. So normal alkanes on heating with AlCl3 in the presence of HCl, you are going to get branched alkanes. So you are going to see here, it is going to be 1, 2, 3, 4, 5, 6, n-hexane. If you treat with anhydrous AlCl3 in the HCl, you are going to get various branched alkanes, major as well as minor. Such type of oxidation reactions, you are going to see various combination of products. And also aromatization, always I said 6-membered ring is going to be more stable. So here n-alkanes with 6 or more carbon atom on heating with 773 Kelvin at 10 to 20 atm pressure, the presence of vanadium, molybdenum, chromium. So it is going to be dehydrogenated and cyclized. Once it is getting cyclized, you are going to get a aromatic ring. So n-alkane equal or greater than 6 carbons, you are going to get, let us say n-hexane is going to get cyclohexane, further it is going to give benzene. You are going to end up with a benzene. Okay, beta? Huckel rule we discussed in the previous class. In order to say a compound to be aromatic, we need to use the Huckel rule. So the aromatic compound should have 4n plus 2 number of pi electrons, that is called Huckel rule. Okay. Now let's see aromatization 1, 2, 3, 4, 5, 6, 7. It is heptane. I said 6-membered ring is always stable. So it is going to give you a methylated benzene. So it is called as toluene. It is called as a toluene. Methyl benzene, it is called toluene. Fine, beta. Now reaction with steam. Methane react with steam to give rise the product of CO and H2. Mixture of CO and H2, what do you call? Water gas. Water gas. So it is called water gas. It is a wonderful industrial fuel. It is a wonderful industrial fuel. Right? Any doubt, bacho? We are done with organic alkane part. Okay? And pyrolysis, last reaction. So pyrolysis otherwise is called cracking. Higher alkanes, when it is heated at high temperature without oxygen, you are going to get a mixture of lower alkanes and alkanes. So this is the fundamental reactions we have. This is the fundamental reactions we have for the petroleum refinery. We can get the mixture of lower alkanes and alkenes separated by fractional distillation. This fractional distillation gives various products and separate and sell it as a petrol, diesel, kerosene, blah blah blah. It is going to be heating a substance in the absence of air until it decomposes is called cracking or pyrolysis. Okay? And you see here pyrolysis, heating of a substance in the absence until it is decomposed. So hexane, it is going to heat 773, you are going to get C3, C2, C4, C6 alkane as well as a mixture of lower alkanes. Okay, this process is called pyrolysis. In this pyrolysis, the products that are going to be random depending upon the temperature. We don't have to memorize each and everything, but you need to understand what is a pyrolysis. And also preparation of oil gas from kerosene, we do by using a pyrolysis here. So a dodecane, C12H26, a constituent of kerosene oil, dodecane. If you use a platinum or nickel, you heat it to 973. you are going to get C7, C5 and other products. Now this is going to be subjected for fractional distillation. This is going to be fractional distillation. So separate them and sell it in a different products better, right? Any doubt? That's good. Now alkane reaction is over. So alkenes, before going for the alkenes. So it is more than 1.5 hours we had a class. If it is okay, can we take a break for a 5 minutes beta? 5 minutes break. One thumbs up and fire emoji. So only 5 minutes break we can have. So that the class goes one more 2 hours, not a matter. So I want to complete alkene as well as alkane and some questions as well. Are you getting or not? So let's take a break for some times. So sometime here, let's see. So my dear students, let's start. How to start here? Start. So 5 minutes. Thank you. Stay tuned. Don't leave the class. Thank you. Okay, students, I am back here. So you're able to see me, can hear me. Now we start. Alkenes. Can you all see me? Can you hear me? Just give me confirmation. Just give me confirmation. This chapter will be completed today. So far, filhal aam charcha kiya alkanes. Now we are going to discuss about alkenes. Right, betam? Surya Pratap. Yeah. So we'll start with alkene. What are alkenes? Alkenes are known as olefins because they have the oil forming ability. They form oily liquid on reaction with chlorine. So they are called olefins and they are having a CnH2n molecular formula, and C double bond C is called olefinic bond. C double bond C is called olefinic bond. Yeah. Surya Pratap there in the class. Now let's talk about, before going for this alkenes, a slide, promotional slide here, NEET test series. The link is there in the description box. You just click that link and just go ahead with that. And it is prepared by the NEET faculty, well-proven NEET faculty, and it is according to latest NT examination pattern, and also it simulates the real-time NEET examination. And it is separately prepared in the 3 categories: grade 11 ka, grade 12 ka, and repeaters ka bhi. And before you just pursue this and enter YouTube 30 of coupon code ताकि आपको 30% automatic discount मिलेगा. So NEET test series is the ultimate key to NEET success. ठीक है बेटा? So let's talk about the alkenes, the bond strength and the bond energy. Yes, Anuj. So stronger bond than alkane. So because of the double bond strength and the energies of the alkane. That is the difference between the alkane and alkene. But surprisingly, alkene is more reactive than alkane. Now we see here weak pi bond 284 kilojoule per mole is given. So loosely held electrons, that makes the alkene is more reactive towards the reaction with electrophile beta. So alkenes undergo electrophilic addition reactions. So they show isomerism, they have geometrical isomerism, Cis-Trans isomerism, E and Z isomerism. So the isomers of the compounds have the same molecular formula but differ in their structures. And they show stereoisomerism, geometrical isomerism. So the pi bond prevents the restricted rotation. So this gives you the 2 different configuration, gives rise this geometrical isomerism. Restricted rotation means this bond you cannot rotate in this way. That is what is called as restricted rotation. Anuj, yeah. Right. Now in this way, different groups should be attached to each doubly bonded atom to show geometrical isomers, because these differ in their length L1 and these differ in the length L2. So L1 is not equal to L2, they differ in the geometry, right? And nearly in the same plane. Now I want to say, if cis is a form with a similar group on the same side of the double bond, and that is called as a cis form, and a trans form, same group on the opposite side, is called as trans form. And the condition for the geometrical isomerism, you see, एक कंडीशन है डबल बॉन्ड रिस्ट्रिक्टेड बॉन्ड रोटेशन होना चाहिए, and A and B and X and Y. So here A double bond का हिसाब से A should not be equal to B and X should not be equal to Y. So that is the condition to show the geometrical isomerism. In the NEET examination, you will be asking a question, which of the following will show geometrical isomerism? In which of the following geometrical isomerism is not possible? Kind of questions are very important. And also you see here, so preparation of alkenes from various sources. You can prepare from alkyne, you can prepare from alkyl halide, you can prepare from vicinal dihalides, you can prepare from alcohols. So this is the area where you need to focus on more. Definitely you are going to get a question based on this. So preparation from alkenes, preparation of alkene from alkynes. You can undergo partial hydrogenation. A beautiful presentation is there, I just want to show you. You can use the two types of catalyst, either Lindlar's catalyst or liquid and sodium, liquid ammonia and lithium or sodium metal can be used. So those students, please write a noteworthy point. Mechanism भी दे सकता हूँ आपको. And Lindlar's catalyst क्या हो सकता है? You can use barium sulfate and palladium. You can use CaCO3 and palladium. You can use lead carbonate, palladium you can use, anything you can use. And you need to use quinoline as a solvent. It is not a reagent. Okay, I'll show you the reagents and the reactions. Controlled hydrogenation of alkane. Before controlled hydrogenation, I want to show you exhaustive hydrogenation. Hydrogenation in the heterogeneous catalyst. Alkyne, when you use directly hydrogen in the palladium, you are going to get completely hydrogenated. So this is what is called uncontrolled hydrogenation or exhaustive hydrogenation. Uncontrolled hydrogenation or exhaustive hydrogenation. यहाँ पर आप reaction नहीं रुक सकते हैं बेटा. You can use a partial reduction by using Lindlar's catalyst बेटा. This is very important. You can see alkyne is reacted with H2 and palladium and calcium carbonate or lead carbonate. We जो reaction, this is what is called as a quinoline. This is what is called as a quinoline. Okay, quinoline acts as a solvent, and you are going to get a cis product, and it is called as a syn addition. आपको पता क्लियर? And I already mentioned what is a syn addition or anti-addition. Addition to the one side of the double bond is called as a syn addition, ताकि आपका cis product मिलेगा. And also you can use a partial reduction with sodium and liquid ammonium. This is called Birch reduction. And in this Birch reduction, you can use sodium or lithium. You can get anti-addition. You can see this hydrogen is being added in the opposite side of the double bond. That is called anti-addition. This anti-addition gives you the product in this way. So trans product you are going to get. So it is going to be very important. NEET examination, maybe CBSE से NEET तक जर्नी में आपको पूरा इसका देना चाहता हूँ. And also exhaustive hydrogenation देना है. Mechanism थोड़ा elaborate करके देना चाहता हूँ आपको. Okay, alkyne, H2PD. You are going to see the exhaustive hydrogenation. थोड़ा सा mechanism. I said it is a surface catalyzed. So that hydrogen जो है ना palladium surface में adsorb करके आपका palladized hydrogen is going to be added to the carbon to carbon triple bond, so that you are going to get a alkene. यहाँ पर reaction नहीं रुकेगा, ये आगे बढ़ के क्या होगा और एक हाइड्रोजन ऐड करके आपका सीधा मिलेगा final product is going to be the alkane. Okay, this is the mechanism, surface catalyzed mechanism, syn addition we already discussed in the alkane preparation. But I want to discuss this in the exhaustive hydrogenation में. I यहाँ पर रुकना चाहता हूँ मैं. कैसे रुकना चाहता हूँ? Palladium जो metal है ना, act as a catalyst, and you just apply some catalytic poison like barium sulfate and calcium carbonate or lead carbonate जैसे. So in this you can see, if you use a calcium carbonate as a catalytic poison, आप barium sulfate भी इस्तेमाल कर सकते हैं. So ये क्या कर सकता हूँ? palladium का catalytic activity से रुक देता, so that what will have a syn addition का alkene का तक reaction आके रुक जाएगा. You can see the same thing can happen and you are going to stop the reaction here. So syn addition product cis alkene is formed and this reaction is going to be stopped here. Are you getting or not clear? Any doubt? Array, you can ask doubt. Surya Pratap, Jay Kumar, Anush, Betu, all the students, please. Now, example, this is the concept you study, but in the examination, the question will be given like this. आपको डराने के लिए, okay? So answer क्या दे सकता हूँ? When you see this big structure, ना, when you see this big structure, you will afraid, but you don't look at this. H2 in Lindlar's catalyst सिर्फ ये ट्रिपल बॉन्ड रिएक्ट करके आपका हाइड्रोजन सिस प्रोडक्ट बनेगा, so that it is going to be cis or Z configuration is formed. This is the actual product. समझ में आ रहा है क्या? No doubt. That's good. Nice. Writing along with me, Surya Pratap. That's good. Perfect. Perfect. And controlled hydrogenation में Wurtz reduction भी है. So you can see sodium in liquid ammonia. It is going to give, sodium is going to form sodium plus an electron दे दिया ना, that electron is captured by the alkyne triple bond, so that you are going to get anion as well as a radical. ये weird condition है. ये जैसे weird condition में ये वाला एक प्रोटॉन या अमोनिया से पकड़ के एक हाइड्रोजन यहाँ पे पकड़ेगा, so that a free radical फिर इलेक्ट्रॉन पकड़ के you are going to get again ion, and this ion is going to take this proton from ammonia to give rise one hydrogen this side, another hydrogen the opposite side. The final product is going to be anti-product, appears like this. Clear beta? You love it? Those who are online, please give me thumbs up and fire emoji in the chat box so that the session energy is going to be increased, and please like the session. Please like the session. When you like the session, na, the number of likes increases continuously, so हमको दिखाया जा सकता. ठीक है बेटा? Right. And एक क्वेश्चन आपको पूछना चाहता हूँ. What is this? This is the one. If sodium in liquid ammonia, you are going to get anti-addition, and you are going to get NH2 minus as a byproduct, so super basic as a co-product. That is going to be a source of proton. So you can use sodium bisulfite or ammonia. I prefer this. Whenever sodium bisulfite is seen, don't afraid of this. ये भी एक काम कर सकता हूँ. Yeah, I know your Betu. Okay, no problem, beta. Betu, fine. Let's see here. If this is a structure, sodium in liquid ammonia, you're going to get two hydrogens in the anti. It is an anti-addition, and it is going to be trans product. It is going to be trans product. Anti-addition, अपने trans product दे सकते हैं. And you see H2 and H2. You can say H2 in Lindlar's catalyst, you are going to get a product like this, cis product. Cis product means the hydrogens that are being added are in the same side of the double bond. Okay, same side of the double bond. And I have a question. If a double bond and a triple bond are there, you can use H2 and a PD. You are going to get complete hydrogenation. This is what is called as exhaustive hydrogenation. Now you see here, when a double bond or triple bond is there, if you use a Lindlar's catalyst, it is going to be what's Lindlar's catalyst? Omkar Chavan I am going to tell you, and it is going to get controlled hydrogenation का हिसाब से, it is going to be controlled hydrogenation. ठीक है? Any doubt? So what is Lindlar's catalyst? Lindlar's catalyst होता है बेटा, this is palladium in barium sulfate in the presence of quinoline as a solvent. In the presence of a quinoline as a solvent, this is what is called as a Lindlar's catalyst. ठीक है बेटा? Any doubts? बेतो? Definitely I'll help you, Betu. Definitely, don't worry. Right? Moving ahead. Yeah, this is already completed now. This is already completed, and we'll go ahead with dehydrohalogenation. Yeah, preparation of alkene by dehydrohalogenation. Preparation of alkene by dehydrohalogenation. You see here. So, elimination of HX is called as a dehydrohalogenation. Elimination of H as well as X is called as dehydrohalogenation. The reagent you can use alcoholic KOH. You can use alcoholic KOH, I mean to say potassium hydroxide in the presence of alcohol. Beta, you need to use heating. Elimination always is endothermic reaction, so that heating is required. Hi, Holly, Namaskar, Om Prakash Shavan. Please like the session, both of you. You can use C2H5OH and C2H5OH and you heat it, and you are going to get RONA and ROH and you heat it. Whenever heating is there, it is supposed to be given elimination product. Bacho, it's very important, very, very important. Most of the students will get a difficulty in this. I am going to help you out of this, Bacho. This is very, very, very important, very important. Okay. Now, here you can see actual elimination reaction में क्या करना. This is a leaving group. जो कार्बन लीविंग ग्रुप पकड़ते हैं ना, ये अल्फा कार्बन होना, इसका जो बगल वाला जो कार्बन है बीटा कार्बन होगा. सो ये बीटा कार्बन में एक हाइड्रोजन होगा. ये बीटा कार्बन हाइड्रोजन निकाल रहे हैं ना, इसी का कारण ये बीटा एलिमिनेशन बोलना है. आर यू गेटिंग और नॉट? सो दैट halogen from one carbon atom and hydrogen from its adjacent carbon atom, both are removed, and you are going to get a double bond here. So this is what is called as alkene. So two sigma bonds are lost, one pi bond is introduced. This is an endothermic process. This process is called as a beta elimination process, right? And actually this potassium hydroxide K plus and OH minus this OH minus is a base, and this is a base, and this is a base is going to take the halogen is a negative, so that makes this beta hydrogen positive, so that base is going to take this and you are going to get an alkene. So there is a transition state, and it could be having E1 elimination process or E2 elimination process, and the detailed version about this E1, E2 we are going to discuss in the current topic, or else you can talk in this alkyl halide as well. But as you are in hydrocarbons, let me give you more emphasis here. Okay. Any doubt? Fine. Omkar Chavan and Holly 3634. Let's discuss some more. Anush, Surya Pradap, come on. Now here what happened? In most of the elimination reactions, where are the two or more beta hydrogens that are available, so that hydrogen should be eliminated from only one of the beta hydrogen, which bears the least number of hydrogen atoms, ताकि the most substituted alkene is formed. This is actually given by the Zaitsev rule or Zaitsev rule. And you have a lot of confusions when to use Markovnikov rule, when to use a Zaitsev rule. Zaitsev rule you have to use when elimination takes place. Markovnikov rule when to use when addition takes place. You just keep this thing in your mind, you can do the best. So बच्चों, Zaitsev rule अलग नहीं है, Zaitsev rule अलग नहीं है, ये इंसान का नाम भी एक ही है, ये रशियन नाम है ना, रूस से अंग्रेजी तर्जुमा करने के वक्त में ये स्पेलिंग बदल दिया अलग अलग टेक्स्ट बुक में. ओके हॉली. So Zaitsev rule and Zaitsev rule is same and the person is also same. ठीक है बेटा. And also you see, whenever you have this bromine, okay, this is alpha carbon, and you have this is a beta carbon and this is a beta carbon. Okay, I want to say beta 1 and beta 2. If I remove beta 2, this is the product, and if I remove from beta 1, this is the product. Okay, and this is the major product क्योंकि ये elimination में this is the most substituted alkene. When during the elimination process the product formed is going to be more substituted alkene. This is what is called as a Zaitsev rule or Zaitsev rule. समझ में आ रही है बेटा बच्चों? That's good. And the opposite can take place. Hoffman product, I don't want to discuss. In most of the cases you are going to see the beta elimination. Elimination reactions are so many types, and 99% of the elimination reactions are beta elimination reactions. So in the beta elimination reactions, most of the cases Zaitsev rule भी इस्तेमाल करना, Hoffman rule नहीं इस्तेमाल करना. Hoffman rule कब इस्तेमाल करना? I'll tell you. This is what is called as a Zaitsev product, and this is what is called as Hoffman product. So most of the cases Zaitsev product is formed. Hoffman product is formed whenever the leaving group is a poor leaving group, whenever the base is a bulky base, and thermal decomposition reactions, this Hoffman product has to be used. Okay, Holly and Omkar Chavan and Betu and Anuj, those who are online, please keep asking doubts so that आपको मिलेगा क्या क्या करना है. And you see some more reactions I want to show you. Right. Now you can see the reactivity in the dehydrohallucination. Alkyl halides is more reactive than alkyl bromides, is more reactive than alkyl chlorides, is more reactive than alkyl fluorides. बच्चों alkyl fluorides कभी react नहीं होगा. Okay, क्योंकि carbon to fluorine bond is so strong. Whenever rate of reaction, tertiary alkyl halides are more reactive in elimination reaction than the secondary than the primary. Okay, that is also very important here. And which of the following can react faster? So I just want to talk about the vicinal dihalide and the geminal dihalide beta. If two halogens are present on the same carbon, is called as a geminal dihalide. Okay, and two halogens are present on the adjacent carbon atoms is called as a vicinal dihalide. Okay, geminal dihalide and vicinal dihalide. So we will take in both cases to talk about these products. Okay, talking about by dehallogenation of elimination of halogens takes place. So the reagent you can use sodium iodide in acetone, okay, zinc in the presence of acetic acid or ethanol, and you can use zinc and directly you can heat it. अरे बेटा sodium iodide in acetone कहीं देखा ये वाला? Those students who are online, please let me know in the chat box. Have you ever seen this sodium iodide in acetone? Anybody? सोडियम आयोडाइड इन एसीटोन. अरे फिंकलस्टीन रिएक्शन में देखा, फिंकलस्टीन रिएक्शन में देखा ना. जय कुमार, you come back to live, very good. And Holly and Om Shavan, Omkar Shavan. So sodium iodide and acetone is used 2 times here, dehallucination reaction as well as a Finkelstein reaction. Okay, and talking about here, when vicinal dihalide is heated with zinc and acetic acid or sodium and acetone, these two are eliminated so that this bond is shifted here, this bond is shifted here to give rise an alkene. Right? Keep asking doubts. Keep asking doubts so that let's see the mechanism. Mechanism इतना काफ़ी important नहीं है, आपको सिर्फ दिखाना चाहता हूँ. When it is heated with zinc, you know, it is going to give you, this is going to be shifted as last year. So carbanion is formed, this carbanion is going to lose its bromine to give rise an alkene. And even in the sodium, in iodide, in the presence of an acetone, you are going to see the alkene as a product. You are a new subscriber too. There are so many subscribers, 3.5 million subscribers are there in the Infinity Land NEET YouTube channel, bachcho. And congratulations, become you are my new subscriber in this channel. Okay, moving ahead, preparation of alkene from alcohols. You can prepare alkene from alcohols by acid-catalyzed dehydration. That's very, very. Which class you are taking? Jay Kumar, I am taking a NEET class, chemistry, organic chemistry. So elimination of water is called as dehydration. In this dehydration reagent, you can use concentrated H2SO4. You can also use anhydrous Al2O3, or you can use KHSO4 and you heat it. Always you have to heat whenever you are eliminating. Whenever you are eliminating, you have to heat it. Fundamental rule in the organic chemistry. Okay, but so you can say this is your tertiary butyl alcohol. When it is heated with concentrated H2SO4, you are going to remove this OH and one hydrogen from here, you are going to get an alkene. Okay, so beta hydrogen is removed, hence it is called as again the beta elimination reaction, bachcho. Again it is a beta elimination reaction. Okay, and you see what is the mechanism? The lone pair of electron present on the oxygen is a Lewis base, and the OH is a poor leaving group. So this Lewis base is going to attack on the H plus given by the acid to get protonated alcohol, and this is a good leaving group. So it is a good leaving group, making this bond weaker so that it is lost as a water molecule. So you're going to get a carbocation. Thank you very much, Jay Kumar. Thank you. Yeah, thank you very much, Jay Kumar. So this carbocation that is formed is going to be deprotonated. So by this water or conjugate base to give its corresponding alkene. The reaction proceeds in the direction a sigma bond is removed and a pi bond is introduced. So simple reaction. You can say, unless there is a rearrangement, if you want to say this is your alcohol, this is not a phenol, cyclohexanol. If you heat it H plus and you just heat it, you take this and take this alpha carbon and beta carbon. So ये दोनों का बीच में एक double bond लगाना है. So this is how you are going to get a product. That's it. Unless there is a rearrangement, so you need not have to worry about that. So rearrangement के भी हिसाब से देना चाहता हूँ मैं. ठीक है बेटा? Any doubt? Now look at this, ease of dehydration. So tertiary alcohol is more reactive. Ease of dehydration, carbocation stability का हिसाब से ये form करना है. So you have 3.85 million and they are seeing 11 members only. Why? Because this particular ACE वक्त में these many students are attending and these subscribers are attended and they are with they passed as well. Okay, ease of dehydration depends upon the stability of the intermediate, that is carbocation, that is formed. Here कौन सा carbocation form किया? ये tertiary carbocation form किया. ठीक है? And this is the trick you need to know. Based on the trick, NEET examination, you will be having a question. Which of the following alcohol can be easily dehydrated? Easily dehydrated. That type of questions definitely we will be doing now. Okay, if you are ready, we can do it. Some primary and secondary alcohols also undergo rearrangement according to the action. Whenever carbocation is formed, it has the ability to rearrange. So, more stable carbocation has to be formed from its less stable carbocation. So, the order of stability of the carbocation, tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. Got it? Now, let us see order of reactivity of alcohols. So, this is isomeric alcohol, this is a tertiary alcohol क्योंकि OH tertiary carbon में है. This is secondary alcohol क्योंकि OH secondary carbon पर में, and this is a primary carbocation can be formed. This is a primary alcohol. Tertiary alcohol is more reactive than secondary than primary. Okay, and you see some alcohols also undergo rearrangements. I will show you how they undergo rearrangement. If this is the case, it can undergo rearrangement. Whenever it undergo rearrangement, generally in the dehydration of alcohols, HF products are the major products. So then what's your name, beta? What is your name, beta? Okay, here you see, this is the major product. It is 80% is formed because more substituted alkene is formed as a product. So that is called as a CHF product. Okay. Now let's see migrating tendency in the during rearrangement, hydrogen or methyl or alkyl group is going to be migrated from one place to another. So hydride shift is more than phenyl shift is more than alkyl shift. When it is going to be alkyl shift, tertiary is going to be more than secondary is going to be more than primary. So this is a super important carbocation rearrangement. This is very, very important. Whenever you form a carbocation, you follow this. Everybody? Can you all able to see me? I am changing the board. So we are having the what we say super sophisticated studio over here for the students only. Right? Now, any doubt? Now moving ahead, dehydration of 3-methyl-butan-2-ol. So whenever this is formed as a carbocation, okay, this carbocation can have various possible structures, can have this, can have this, can have this. So among this, which is a major product? So we can going with these various probable structures of the intermediates that can be formed, and also I am going to give you how the rearrangement takes place. Okay. Jai Kumar, Anuj, you are not talking to me, why so? If you want one more break also I can take, no problem. Nikhil, the most powerful person in the future. Nikhil Jai Kumar. Okay, definitely. You see, once this is a OH group, is a poor leaving group, this poor leaving group is going to be protonated, so that this lone pair of the electron present on the oxygen given to the H plus 2 gives rise a protonated alcohol. This is a good leaving group. This is going to be lost as a water molecule, so that a carbocation is formed. This carbocation is a secondary carbocation. Secondary carbocation nickel is less stable, ताकि ये जो bond है ना, this is going to be shifted from here to here, so that you are going to get a tertiary carbocation. As I said, tertiary carbocation is more stable than secondary carbocation, is more stable than primary carbocation. And this tertiary carbocation is going to deprotonate from here, okay, from here, and you're going to get the possible product. You see, this is going to give you the possible product as a major and the possible product as a minor. Any doubt? Nikhil? So, just observe how the products are being given, Bacho. How the products are given. You see, these are the three possible products. In these three possible products, how do you get a possible product here? The mechanism के हिसाब से आपका कार्बोकैटायन पहले जो फॉर्म करना है, ये जो mechanism, carbocation is going to be rearranged, secondary carbocation is going to be converted into tertiary carbocation. This carbocation is going to give the possible product as, if this hydrogen is lost, okay, this is the product. If this hydrogen is lost, this is the product. You understand? Nikhil, got it? That's perfect. Now, one more example. This is what is called as a Sedgwick product, and this is what is called as a Hoffman product. Okay? So, the most powerful person, we are talking with the most powerful person, Nikhil. And Betu, if you have any doubts, please let me know. If you have any doubts, please let me know. Fine. Now, physical properties of alkenes. So, physical state, color, order, solubility and the boiling point we follow as just it is got with an alkane. Oh, questions aane wale hai. Rakesh, after completion of alkenes, we talk about alkynes, then we start with the questions. ठीक है, टाइम लगेगा और 1 घंटे लगेगा. Stay tuned in the class and please like the class. Okay, राकेश गेमिंग, क्वेश्चंस आ सकता है और 1 घंटे लगेगा. So let me finish quickly. So 2 carbon atoms, 2 to 4 are gases, 5 to 18 are liquids, and 19 onwards are going to be solids. ठीक है बेटा. And also alkenes are colorless. Number of carbon atoms in alkene and order 1 to 2, faint sweet smelling beta. क्या सूर्य प्रताप delete होना है रही है. Okay, greater than 3 they are going to be orderless. Okay, they have no smell. Alkene solubility, they are soluble in non-polar solvents, they are insoluble in water. Okay. And boiling point increases with increase in the molecular mass. Boiling point directly proportional to van der Waals forces and is directly proportional to the molecular mass. And you see, like alkanes, straight chain alkanes have the higher boiling point than their branched one with the same molecular mass. Right, beta? And also, you can see 2-methyl propene and but1-ene. These two are having, you see, -7, -6.5, because this has a branching, right? Okay, beta? Any doubt? Clear? And moving ahead, so chemical properties of alkenes. They undergo electrophilic addition reactions, and they undergo oxidation, ozonolysis, polymerization. And if you are good at this addition reactions na, and ozonolysis, na, 1 mark is yours. हिंदी में भी एक्सप्लेन कर सकता हूँ क्योंकि ज़्यादा लोग इंग्लिश में कंफर्टेबल है. ओके, व्हाट आई एम राइटिंग इज डिलीटिंग, गेटिंग डिलीटेड. क्यों? नो नो नो, ऐसे नहीं होगा बेटा. रामकृष्णा, प्लीज लाइक द सेशन. ओके, जय कुमार. Bhai sir, good morning. How does it mean by congruent? I don't understand. Okay, Jai Kumar, come on. Let us talk about addition reactions of alkene. Alkenes are rich source of loosely bonded pi electrons. ये जो कार्बन टू कार्बन बॉन्ड है ना, उसमें एक सिग्मा बॉन्ड है, एक पाई बॉन्ड है. जो बॉन्ड है इट इज लूजली बॉन्डेड ताकि इलेक्ट्रोफाइल का अटैक जल्दी कर सकता हूं. ओके, राइट बेटा. सो कैसे कर सकता हूं? देखो, alkene when it is treated with H2 and PD, PT or any catalyst, you got an alkane. So this is the case. We use oil which is a vegetable oil. When you add hydrogen and nickel, you're going to get margarine or vanaspati kind of things. This you learned in the school days, right? This is called catalytic hydrogenation. But in the case of halogenation, you have the chemical test as well. You see, so addition of halogens, you can add a reagent. आप Br2CCl4 इस्तेमाल कर सकता, Br2 और H2O भी इस्तेमाल कर सकता, Cl2CCl4 भी इस्तेमाल कर सकता, Cl2H2O भी इस्तेमाल कर सकता. एंड सो ए Br2CCl4 जो ये रेड कलर है ना, ये रिएक्शन करने का वक्त में रेड कलर डीकलराइज होगा. सो दिस इज यूज्ड एज ए टेस्ट. यू कैन सी bromine water test for saturation, for unsaturation. So bromine water, orange color or red color is added to it. So if you added to a saturated compound, चाहे ये alkane हो सकता, alkane को add करो, कुछ नहीं होगा, there is no change in the reaction. If you want to add to the alkene or alkyne, okay, or alkyne B, this red color is decolorized. Okay, you don't worry Anuj, I reply only for academic doubts. Okay, please. Rakesh, I'll explain you. Please like the session because I like the like button, so press it. Okay, now actually this is the test. So what exactly? Addition of halogens to alkene is an example of electrophilic addition reaction. It involves non-classical carbocation intermediate, and when the bromine is added, red color is decolorized. So if you take this test, okay, this reaction, it is used helping as a test to identification of a carbon to carbon multiple bonds. Okay, right. Now, so what exactly happened? So it is a propene. When bromine is added, you are going to get a non-classical cyclic cyclobrominium ion is formed. So that bromide is going to attack on the opposite side. So it is absolutely, it is an anti-addition. So what is the meaning of anti-addition? Addition of something opposite side together of a double bond is called as an anti-addition. It's very, very important, and it is a stereospecific reaction. Okay, and you can see what are the remarks here. So it is an anti-addition. So whenever it is anti-addition, bachcho, it is a stereospecific. What is the meaning of stereospecific here? So ATM and CAR. So anti-addition to trans-alkene gives a meso product, and cis-alkene on anti-addition gives as a racemic mixture. Yes. So hope you understand this, right? Anuj, hope you understand. and who is that? Rakesh, hope you understand. Right. So there is no rearrangement. There are two types of carbocations: classical carbocation, non-classical carbocation. Classical carbocation आपका हिसाब से rearrangement कर सकता है, आप जो carbocation आपको पता है. Non-classical carbocation is a cation. ये ऐसे carbocation है, it is not going to rearrange. It is non-classical, not ordinary carbocation. Cyclobrominium ion, it do not rearrangement. Okay, that's a very, very important point. So you don't rearrange here. And also propene is going to give risk. This is reddish brown color, become colorless. It's a test for unsaturation. It's a test for unsaturation. And addition of HBr, it's very important. HBr means HX. So reactivity here, HI is more reactive than HBr is more reactive than HCl is more reactive than HF. Whenever fluorine is coming, it is not at all participating in the reaction. Addition of HBr. HBr means H plus Br minus. So to the symmetrical alkene. Symmetrical alkene means जो alkene है ना, isteric and isteric both sides are same, is called as symmetrical alkene. You can add H plus here and Br minus here, you are going to get the product like this. When unsymmetrical, this is also symmetrical alkene. A double bond के हिसाब से इस तरफ and इस तरफ both are same ना, you are going to get the product like this. Are you getting or not? So no no issue in this. If I want to add this HBr, क्या करूँ बच्चों, क्या करूँ? Simply add hydrogen there and a bromine there, or bromine there and hydrogen here. Are you getting or not? Now तकलीफ शुरू करता है. मार्कोनिकॉफ रूल आना है अगर अनसिमेट्रिकल आल्कीन होगा तो. सो ये प्रोडक्ट कैसे बनाना? अरे बच्चों डाउट होने तो पूछना जल्दी. जल्दी डाउट होने तो पूछना. Now moving ahead, addition of HBr to unsymmetrical alkene, H plus and Br minus. So this is unsymmetrical alkene. What is the meaning of unsymmetrical alkene? Double bond जो है ना, this side is different and this side is different. This is called unsymmetrical alkene. Okay. So that it has to follow Markovnikov rule. In that, this is going to be the major product. What this major and this is going to be minor. क्योंकि ये वाला negative part of the reagent is going to attach to the carbon of double bond which bears the least number of hydrogens. That is what is called Markovnikov rule. Okay, this is called, in the modified version of the Markovnikov rule is also be given here. The ionic addition of unsymmetrical reagent to the double bond, the positive part of the added reagent attaches to the itself to the carbon atom of the double bond so as to yield the more stable carbocation as an intermediate. Okay, and based on this you can see attack of the double bond, H plus पहले add करना. If you attack here, you are going to get a primary carbocation. There is another possibility you are going to get a secondary carbocation. So in this primary and secondary carbocation, this is more stable. So the more stable intermediate always gives the more stable product. Are you getting or not? Clear? So this is the more stable. Br minus add करके आपको क्या मिलेगा? You are going to get 2 bromopropane is the major product. So whenever rearrangement is there, don't use Markovnikov rule. Are you getting or not? Clear? So here, if this is the case, this is the major product and this is the minor product. Are you getting or not? Fine. Got it? Expecting doubts from the students. I will be more comfortable if you ask more doubts. Now, one more order of reactivity of hydrogen halides. HF is less, HCl, HBr, Hi is more reactive. And also, when alkene is treated with HBr in the presence of a peroxide, okay, you are going to get the product different from the previous one. It is going to be here, you can see this is an electrophilic addition reaction. But in the presence of a peroxide, you are going to get free radical addition. It is going to be free radical addition. So this is called as a peroxide effect or Anti-Markovnikov addition, or you can say it is a Karash effect. So this effect is going to be seen. You can say this is a peroxide, benzoyl peroxide. You are going to get, this is a major product. So the mechanism of this Anti-Markovnikov addition is a free radical chain reaction, addition reaction. So the mechanism नाम भी बहुत important है. ओके, जब खाली HBr इस्तेमाल करो alkene addition के लिए, अब electrophilic addition होगा. अगर ये HBr added in the presence of a peroxide, you are going to get free radical addition होगा बेटा. That's a very important. And you see this और एक चीज़ है, this Anti-Markovnikov peroxide effect है ना, this is only applicable for HBr. So NEET में इसका रीजन भी कैसे पूछना है. So this is a session that is happened with a senior faculty, me and you guys, future doctors. And I am going to give you, I am not singing the concept that is already present in the various textbooks. My experience is blended and giving the best out of your NEET examination. So take use of this and let me tell you what exactly is happening and the reason. So the peroxide is going to take the homolytic cleavage to give rise this peroxide, and after loss of the carbon dioxide, phenyl free radicals are generated. This phenyl free radical is going to attack on this HBr to give rise the benzene, and the bromine free radical is generated. This bromine free radical is going to attack this carbon double bond of the propene. You are going to get two possible free radicals, and this is your secondary free radical, and this is a more stable free radical as compared to this. You know the so the alkyl free radical primary is less stable than secondary, is more stable than tertiary. So you are going to get the various possible free radical stabilities. So from there, this is more stable, this is going to be more stable beta. Once this is stabilized, it is protonated, this is protonated from HBr to give rise as the major product. 1-bromopropane is the major product. And I'll tell you how to handle the questions in the NEET examination, children. Okay, you see, CH3, CH double bond CH2, if you add various reagents, okay, Br2 CCl4, you are going to get CH3, CH and CH2, you are going to get bromine and bromine, right? If it is HBr, you see, this is how you have to prepare for your NEET. HBr, you are going to get CH3, CH, and CH3. If we want to add HBr in the presence of peroxide, the product you are going to get CH3, CH2, CH2Br. If it is in the presence of Br2 and in the presence of heat and light or N-bromosuccinamide, you are going to get allylic bromination. So without double bond disturbance, you are going to get allylic bromination. That is also super important. You have various types of equations for that. Bacho, you kept quiet and I want you to be interactive in the class. So in the class, this subject is going in such a flow that you never skip any topic from the NEET examination. So never leave the marks on the table, take the marks in your pocket, and the journey towards dream medical college is all yours. Fine, agree, any doubt? Now, Bacho here. So attack of the forward radical, you are going to give the minor product, okay? Now, cleavage of HCl, the proper reasoning is also there, already given a question. So, the cleavage of HCl-HF bond by alkyl radical is endothermic. So, that peroxide effect is not work with HCl-HF. Therefore, if we want to just take HCl with this free radical, this is endothermic, a reaction again badta. So reaction of alkene with I is endothermic, so that it is also the same case. So at the end, a long story in a short, peroxide effect only work with HBr, but not with HF, HCl, HBr. The reason is given here, everybody take a note of it. Fine. Break it now. Break it down. Break it down. Break it down 5 minutes. Okay, moving ahead, addition reaction here. Now, propane, when it is treated with HCl, if you use a peroxide also has no effect. You are going to use a Markovnikov. And HI also you are going to have no effect. So it's a trap, actually it's a trap. Don't get trapped when the peroxide is used. And also addition of water, addition of H2O, it takes the Markovnikov addition reaction. Addition of water is called hydration. Hydration can take place in 3 different versions. In alcohols, I already discussed it in the previous long ago, and I will discuss it again later. And alkene, water is added in the presence of H2SO4. You can use any acid. You are going to get alcohol. It is an electrophilic addition reaction. Bacho, first step is alkene. You are going to get protonated to get a carbocation. I already mentioned the carbocation has ability to rearrange. So that water being a Lewis base here, it is a Lewis base, the lone pair of electron in the presence of the water is going to be given to the carbocation to give rise a protonated alcohol. This protonated alcohol can be deprotonated and gives rise its corresponding alcohol. And that's very important. And we can have addition of sulfuric acid, and addition of water can have the mechanism in the different formats. Bacho, let me have a couple of minutes break. So can we take a break to complete these alkenes and alkynes? Then we can start with some questions as well, right? So I want to take you to the other level of this hydrocarbons. Stay tuned, Bacho. Stay tuned, right? So Let's meet after 5 minutes. ठीक है? Take care. So I am back, my dear children. Thank you for your cooperation. Here addition of halogen reaction. So Jai Kumar, are you there? Right. So those who are online, please give me a thumbs up and fire emoji. So moving ahead here, addition of mechanism, addition of water. So you can see alkene, this is your alkene. You can add water by using 3 different methods. One is acid-catalyzed hydration, another one is hydroboration oxidation, and oxymercuration demercuration. Just I want to give you outline about this. Acid-catalyzed hydration, carbocation is formed and you have to follow Markovnikov rule. If carbocation is formed, rearrangement takes place. When you talk about this hydroboration oxidation, it is the product is formed according to Anti-Markovnikov addition. There is no rearrangement. When you add oxymercuration and demercuration, you are going to see Markovnikov addition, but seriously there is no rearrangement. There is no rearrangement. समझ में आ रहे क्या बच्चों? And this is very important aspect. What are the reasons that you can use it? In acid-catalyzed hydration, you can use dilute H2SO4. In hydroboration oxidation, you can use BH3THF and NaOH and H2O2. And oxymercuration demercuration, you can use mercuric acetate and water and sodium borohydrate and sodium hydroxide. So moving ahead, addition of sulfuric acid. You are going to get bisulfate adduct product. You have to maintain low temperature as 413 Kelvin. You have to use the low temperature as 413 Kelvin or less than that. If you use more than that, it is going to be a different product. So oxidation of alkene, that's very, very important beta. So we study this as an alkene only. So cold dilute alkaline KMnO4, that is called Bayer's reagent, pink in color. You are going to get a pink in color. And basic KMnO4, acidic KMnO4 and acidic K2Cr2O7. They are super strong oxidizing agents. And hydroxylation takes place and carbon to carbon bond cleavage takes place. So in this case, what will happen? So in this case, you are going to get from here to here, you are going to get syn hydroxylation. In this case, what will happen? Alkene is going to break its bond to give rise C double bond O, C double bond O. It could be a carboxylic acid as well. So this is the way you need to study the organic chemistry super command you need to have in your hand. Right? Bacho. So moving ahead. So what happened? In alkene is there here. If you add a purple color, cold KMnO4 is added. If you have positive test, KMnO4 is getting decolorized. So little bit of MnO2 gives a brown sludge out there and it is called Bayer's test. So we can conclude that इस compound में carbon to carbon double bond है होगा. But there is no change in the color, so it's a negative test. So there is no carbon to carbon double bond in this. And cyclopropane also gives this test because of the ring strain. Okay, beta? That's very important. So in the practicals, the pink color, it was like this, it decolorizes into this. Okay, beta? And so please, if you have any doubts, please let me know. But show oxidation using a Bayer's reagent. Bayer's reagent is going to give a syn addition. So manganate ester, cyclic manganate ester is formed. So MnO4 minus gives rise cyclic manganate ester, and this bond is broken in the presence of alkaline hydrolysis to gives rise cis-diol. So this is going to be syn addition, absolutely syn addition better. Okay, the same thing can be done by using osmium tetroxide. Osmium tetroxide oxidation by using Bayer's reagent. This is used to distinguish between saturated and unsaturated compounds. चाहे unsaturated compounds alkene हो सकता है, alkyne भी हो सकता है. Okay, when you add alkane there is no reaction. Why? Because उसमें pi bond नहीं है add करने के लिए. ठीक है बेटा. And also you see oxidation by using Bayer's reagent. If you take this, you are going to get purple color disappears. You are going to get glycols. Geminal diols are called glycols, बच्चों. And you can see triple bond जो है ना, cold KMnO4 you can add, so that you are going to get a diketone. Alkynes gives diketone, alkene gives diol, vicinal diol. And moving ahead, oxidation by using drastic conditions. So carbon to carbon bond can be broken. So whenever this carbon to carbon bond is given, if you use KMnO4 in the acidic media or basic media, this bond is broken. Carbon to carbon bond is broken to give its corresponding carbonyl groups. चाहे इसको और एक भी हो सकता है. If it is given like this, you are going to get carboxylic acid. So actually this will be given, and retro analysis you have to find the structure of alkene. So this is how the questions can come, right beta? So an example, you are going to get this is a cyclohexene KMnO4, just heat it. The product that is going to be formed here, you break it and you are going to see carboxylic group here. This is part is called oxidized. It is called drastic oxidation. Any doubt? Anuj, Jai Kumar, come on, if you have any doubts, please let me know. Moving ahead, yes, it is oxidation by using basic KMnO4 acidic K2Cr2O7. You are going to simple trick I can give you. Whenever you have a double bond, you simply break this, and make an oxygen over here and oxygen over here, so that you are going to get a corresponding carbonyl groups. Expecting you to give the doubts, so without doubts you cannot enjoy the class. Bacho, come on, aage lagane do. And moving ahead, the most important point here, oxidation in this, even in the alkyne, you have to break this. When you break this, is corresponding carbonyl group is formed. Okay, it could be aldehyde, or it could be a ketone, or it could be a carboxylic acid. But in the case of alkyne, it's supposed to be carboxylic acid. In the case of alkene, you're going to get can be aldehyde, can be a ketone, right? And moving ahead, ozonolysis, the most important part in the total organic chemistry. It is a step holding footpath for your analytic approach of this organic chemistry, bachcho. And let us talk about what is ozonolysis. Alkenes or alkynes or polyenes react with ozone to form a cyclic ozonide or monoxide structures, and it is further hydrolyzed to give rise to corresponding aldehydes or ketones. And based on the products that you got as an aldehyde or a ketone, you can reconstruct the molecule on the paper, that is called retroanalytical way. So that you can locate the position of the double bond. This is called ozonolysis. It's a process. The ozonolysis could be oxidative ozonolysis or a reductive ozonolysis. Mind it, in the oxidative ozonolysis, the product that you are going to get is a carbonyl group. And reductive ozonolysis, the product you are going to get in either aldehyde or a ketone. But in the oxidative ozonolysis, the product we are going to get a carboxylic acid if it is an aldehyde, but ketones it will be as a ketone only. So you can use the reagents as an ozonolysis of these oxidative ozonolysis and reductive ozonolysis. In the reductive ozonolysis, we use zinc. Okay, dimethyl sulfide is a solvent. Okay, I'm expecting you to give the doubts better. In the chat box, you guys kept quiet. Okay, please. In the oxidative ozonolysis, we use directly the ozone and H2O. Okay, and the products in the reductive ozonolysis, it could be either carbonyls, can be aldehyde or a ketone. But in the case of oxidative ozonolysis, ketones and carboxylic acids you are going to get. So alkene you are going to get ozonide, it is going to give an aldehyde or a ketone or carboxylic acid. Hi Kenny, in hydrocarbon organic, yes, in one shot series, this is your one shot series, total hydrocarbons are being completed, and since last 3 hours the session is going on, and one more hour also I am ready to take, and let us follow this. Okay, and you want to watch the recording, you can watch it, and quickly I will finish the concept now. And ozonide is a cyclic peroxide derivative. Children, this is an important peroxide derivative, cyclic peroxide derivative. NEET एग्जामिनेशन में ये ओजोनोलिसिस का हिसाब से क्वेश्चन आने का ज़्यादा संभावना है. So everybody, those who are online, please like this session and please follow and write the noteworthy points so that we can do the best. Okay, and you can see, अरे बेटा इतना कॉम्प्लिकेटेड एग्जामिनेशन में कैसे करो. अरे डोंट वरी, जहां पर डबल बॉन्ड था ना, you just break it and make it oxygen so that CH3 CHO बनेगा बस, and CH2O. the product is easy, जो भी complicated process है, but we are going to make it so easy and simple, right बच्चों? And moving ahead, how to do this? Right, now this is how, let us see. I want you to give the products of this. Here the ozone, मान के चलो reductive ozonolysis कर रहा हूँ. Zinc is a reducing agent बेटा, so which prevents the further oxidation of the carbonyls that is formed. Okay, so you are going to simply break this, simply break this, simply break this. So the product comes as, बच्चों, the product comes as 2 molecules of acetone. Okay, so you are going to get and HCHO, and you are going to get the product like this, CHO and CHO. समझ में आ रही क्या? And mention in the comment box. Mention in the comment box. I am going to give you the question now. How these things can happen? Look at this. Mention in the comment box. O3 zinc H2O. Mention in the comment box. Mention in the comment box. So this is how you need to have a fiery emojis. Fiery emojis. Timestamp में ना, you just mention the answer in the comment box. यहाँ पर product क्या होगा, यहाँ पर product क्या होगा, मान के चलो ये product का नाम है A. So comment box में मैं decode करने के A का product, B का product, C का product. So I want to see आप NEET examination में कैसे कर रहा हूँ. ठीक है बेटा? So there we end with alkene and talking about the polymerization, the last reaction for the alkene. Okay, so polymers are the substance that consist of very large number of molecules that are made from many repeating substituents. Ethene, when it is polymerized by using a proper catalyst, you are going to get polyethylene. We have all the polyethylene. You have two types of polyethylene beta. One is low density polyethylene, another one is high density polyethylene, right? So you see, these are the polyethylene molecule bachcho. So those who are online, I'm requesting you, please like the session and interact with me. So I'm only talking, you are not talking. So LDPE and HDPE, low density polyethylene and these are used in the polythene bags and all. High density polyethylene, you have making containers. You are using HDPE or using for making containers better. And this is the general knowledge. In the polythene container at the bottom of the dabba, it will be written HDPE, LDPE. You can see and understand the meaning of this. ये जैसे symbols कहीं देखा होगा अब? हाँ, yes, it is there. Chemistry, HDPE code number 2, LDPE code number 4. Have you ever wondered about this? Okay, moving ahead. So alkynes, general molecular formula for the alkynes, CnH2n. So this is one minus 2, one short series of hydrocarbons. आज सेशन में सिर्फ हाइड्रोकार्बन्स देना चाहता हूँ. हर सेशन में एक शॉर्ट में टोटल सिलेबस का टोटल टॉपिक खत्म करना है. Right? So alkynes, they have CnH2n minus 2 and they have general formula and sp hybridization. Because of this sp hybridization, the bond angle is going to be 180. And you see bond strength, alkane single bond, sigma bond and a pi bond, and here it is a sigma bond and a pi bond. Two bi bonds का वजह से the bond strength, the triple bond is more than, double bond is more than single bond. So moving ahead, the preparation kind of thing, carbon to carbon bond length inversely proportional to bond multiplicity. Single bond is longer than, double bond is longer than, and a triple bond. Okay, and you need not have to worry to memorize this kind of values here. You see the preparation of alkanes. You can prepare from calcium carbide, you can prepare from vicinal dihalides, you can prepare from lower alkynes. At the end you can see Kolbe's electrolysis as well. Now let's see preparation from calcium carbide. So what is calcium carbide? How do you get? Calcium carbonate on heating user is calcium oxide plus carbon dioxide. This is what is called as calcination. In this calcination you got a quicklime, right? so that it is heated with the coke. It is heated with the coke to give this calcium carbide. This calcium carbide is hydrolyzed to give rise acetylene as a gas. And you know, this combination of reactions are very important in stoichiometry. So it is industrial method of preparation of acetylene or ethine. And also you can prepare from vicinal dihalide. So vicinal dihalide mean to say two halogens are present on the side by side carbon atoms. If you use potassium hydroxide, alkenyl halide is formed. You know, alcoholic potassium hydroxide is going to remove one HBr only. You can't use one more. So it is not that strong base, so that you can use NaNH2. शुरुआत से NaNH2 इस्तेमाल कर सकता हूँ, so that और एक HBr निकाल के आपका alkyne मिलेगा. So this is required. The basic strength of NaNH2 is more than alcoholic potassium hydroxide. That's very important, noteworthy points. You can directly use NaNH2 and you can use, you are going to get alkyne. Okay, you can get alkyne. And preparation of higher alkynes from lower alkynes. You know, lower alkynes, terminal alkynes are acidic in nature. Okay, so this can lose H plus easily. So you can react with NaNH2, so that NH2 minus is going to take this hydrogen to give rise sodium salt. So this is going to be a very good nucleophile, but show this nucleophile is going to react with this alkyl halide by using substitution nucleophilic bimolecular reaction, SN2 reaction, to give rise higher alkane. This is a very important reaction. This is a very important reaction. Okay, any doubt? And Kolbe's electrolysis, an aqueous solution of sodium and potassium salt of malic acid. What is this malic acid? Okay, a trans isomer of ethene so ethene and carboxylic group and carboxylic group. Okay, this is a trans is called a fumaric acid and cis is called malic acid. And this cis is going to be easily decarboxylated because two carboxylic groups in the same side. So you are going to get ethine as at anode. Ethine is at anode. Okay, and you can see this is your malic acid. Malic acid, it is going to decarboxylated to give rise ethine at anode. Ethine is formed at anode. And also physical properties of alkynes. You see where we started, 11 o'clock we started. Okay, alkanes I started, completed. Alkenes completed. Alkynes. Rebeto, how do you selectively reduce an alkyne to a cis alkane or a trans alkane? Betu, we discussed it, na? We discussed it, na? Already we discussed. I am going to give you that. Okay, let me finish that physical properties. So 2 to 4 carbon atom वाला है gases है, 5 to 12 carbon atom वाला है liquids है. Okay, if you ask then I will understand, then otherwise I keep quiet. Greater than 13 carbon atoms are going to be solids. Physical properties, you please don't worry, you please don't worry. Okay, and talking about alkynes are colorless and odorless. Okay, an exception of ethane which has a characteristic odor. Ethine as a characteristic order. ठीक है बेटा? And you know, alkanes weakly polar. In the CCl4 non-polar solvent, it is soluble and it is water insoluble. Right, beta? And also boiling point is directly proportional to van der Waals forces, is directly proportional to molecular mass. Wherever you go in the hydrocarbons, total organic chemistry, this is the following thing. Now chemical properties, very few chemical properties. Okay, acidic nature, addition, reaction, oxidation, ozonolysis. We already discussed this before going for the acidic nature. Alkynes are selectively, you see, Betu, alkynes are selectively converted into alkene by using sodium in liquid ammonia and Lindlar's catalyst PDBaSO4. You are going to get R, C, double bond C, R and hydrogen, R, C, double bond C, R and hydrogen, trans and cis. Remember, we already discussed along with the mechanism, if you know it. So you want me to show this? I will show it once again. Okay, we are in 178 slide now. Remember, याद रखना, भूल जाता हूँ मैं. We already discussed this, if you remember. Beto, we already discussed this, right? If you want to take a screenshot of this, bachcho. Clear? Okay. Now, again go back to long this much discussion we are having. Lot of patience required. Lot of patience required, है ना? Right. So here, acidic nature of alkynes. Terminal alkynes are acidic in nature. Definitely I'll do that. Definitely. The moment I go out of the studio, I will talk to the operator team. They will help you out of it. Thank you very much, Betu. Okay, join in the channel, join in the Telegram channel and message me. I am there in the channel. Okay. And hydrogen bonded. Hydrogen that is bonded at the C double bond C is carbon is sp. So this hydrogen is marked with the red circle. Na? It is acidic in nature. So acidic in nature is directly proportional to electronegativity. You know, electronegativity is directly proportional to percentage of S character. More the S character and more will be the acidic in nature. So sp3 S character 75, 25, sp2 S character 33.3 and sp hybridization S character 50%. जहाँ पर S character ज़्यादा है वो कार्बन का इलेक्ट्रोनेगेटिविटी ज़्यादा होगा. जो हाइड्रोजन ऐसे कार्बन एटम को डायरेक्ट अटैच हुआ होता है, that is going to be more acidic. So that I can say alkyne is more acidic than alkene is more acidic than alkane. Fine, beta. And talking about, so percentage of S character increase होने तो electronegativity increases, stability of conjugate base increases and acidity of a hydrocarbon also increases. That's the reason why the proof that alkyne is an acidic is reacting with NaNH2 gives rise sodium alkoxide. Okay, it can react with sodium metal as well. You can say addition reaction, chemical reactions of alkynes, addition reactions, takes place over the triple bond, so it can take 2 molecules of hydrogen, 2 molecules of chlorine, 2 molecules of HCl. So what are the products? Simple, just like an alkene. So no big game. C triple bond C, HZ, एक H and C plus. Product depends upon the stability of the vinylic cation. You know, vinylic cation is less stable. That's the reason why in electrophilic addition reactions, alkene is more reactive than alkyne. You have number of telegram channels. So you just observe in this lecture, in the description box, the telegram channel is linked there. You just that link only you click it, you will understand. Okay? And also, so addition of Z minus. So zo cation that is formed now, it is attacked with Z minus to get the addition product. Similarly, another molecule of HC can be reacted क्योंकि ये double bond तो है ना, it behave like an alkene तभी. So follow Markovnikov rule beta. Are you getting or not? Clear? And you can add anything, addition reactions of alkanes. You can add hydrogen, you can add halogen, HX, H2O. Addition of H2O is a nucleophilic addition beta. Okay? Now let's see in detail addition of dihydrogen. We learned it exhaustive hydrogenation. Just a while ago we have seen this is called exhaustive hydrogenation. And addition of a halogen. Alkyne react with a molecule of H2 and CCl4 to form 1,2-dihaloalkene. Now it is an alkene. This alkene फिर भी और एक molecule add करके tetrahalogenated product is formed. Like this alkyne Br2 1,2-dibromo फिर भी ए और एक Br2 से react करने तो बाद tetrahalo derivative. Are you getting or not, बच्चों? If you have any doubt, please let me know. All these colorful reactions are made for you, right? Now, alkyne react with HBr. Na? This is a good afternoon, Nandini. You are late. Nandini, you are late. Please make a like button. Please make a like button. Yeah. Me fine, thank you. Me fine, thank you, Nandini. Okay, so HBr is added so that CHBr is formed. Now the vinylic bromide is formed. This bromine is going to add with HBr to form. There are 2 possible carbocations and intermediate. So that 2 geminal as well as vicinal is going to be formed. So as this is going to form a geminal dihalide. Nandini, I remember you are usual regular student in my classes, right, Nandini? Right. So why you are late today? Okay, let's follow. Please first like the session. Please first like the session, bacho. Now addition of hydrogen halides HBr. So we got vinylic halide. Now you can have the other category of the carbocation, intermediate 2. In this you have intermediate 1. Which is more stable? Intermediate 1 is more stable due to positive mesomeric effect. Happy, he is the happy. While you see this is the another possibility of intermediate 2. Okay, this is having negative inductive effect, he is unhappy fellow. It is unhappy fellow. And he is having a positive mesomeric effect, so he is the happy fellow. You came after a long time. I remember every student in my class. Okay? I remember every student in my class. So from now onwards, this is a one-shot series. In one shot, our entire topic will be completed. Total chapter will be completed. let it be the session maybe 3 hours or 4 hours, so that students can get extra benefit. So hydrocarbon you want to study na, you take a 3 months to complete this, but in 3 hours I am completing na, a bala kaam hai, right? I am continuously monitoring the students' doubts as well. Okay, now the intermediate one is more stable, so the product is formed from the intermediate one to get the major product like this, and geminal dihalide is formed. So if you add HBr, you are going to get the bromine, one equivalent, so that bromine. So this is going to be the major, and from there it can be having one more addition of HBr to get again geminal. So you are going to get the major product like this. Follow the Markovnikov rule again. One shot organic chemistry. So one shot organic chemistry में आज हम चर्चा कर रहा हूँ हाइड्रोकार्बन्स. अगले वन सेशन शॉर्ट में आपको मिलेगा क्या एरीन्स in the next session. Nandini, so once you I think you did not subscribe or what? Once you just press the subscribe button, you are going to get all the updates, right beta? And also addition of water. This is a nucleophilic addition. Addition of water require a catalyst called HgSO4. Addition of water require a catalyst here. Now you are going to get vinylic alcohol that is in all form, so it will get tautomerized to get its corresponding carbonyl. So this is called tautomerization. The same thing can happen, bachcho. CH triple bond CH, if you add dilute H2SO4 and HgSO4, okay, if you add water, you are going to get a vinyl alcohol. This vinyl alcohol is going to get tautomerized to give rise acetaldehyde or ethanol. So like that, various products you are going to get it from there. So please do subscribe and press the bell button, you will understand. So what exactly you need to do? We are driving the NEET examination program. So we are not only running the channel, we are giving the best out of these YouTube channels, and we are giving you training to go into your dream medical college, my dear students. So please like this session and subscribe to this channel so that you are going to get all the session updates continuously. So terminal alkynes are less reactive than internal alkynes towards the addition of water. And terminal alkynes will add water in the mercuric Hg2 plus as a catalyst. So in the acidic mixture, right beta? And also you are going to get this propine, you are going to get acetone. Propine you are going to get an acetone. Hey ki na? Right? And this is the mechanism is actually not required, okay, because it is not mentioned, but for your reference I want to give. Note, addition of water is a Markovnikov addition beta, and it's a bridged carbocation. Mercurinium ion bridged carbocation is formed, and no rearrangement is going to be taken place because the vinylic cations are formed. Okay, non-classical carbocation is formed. ठीक है बेटा? And also reactivity of alkene, presence of electron donating group like positive mesomeric effect, positive inductive effect makes C double bond C increases the reactivity, and presence of electron withdrawing groups, it's going to destabilize. Therefore, more stable the carbocation, more is the reactivity. Right? Moving ahead, so the examples here, alkene more substituted is more stable. the stability of this alkene given in the order according to hyperconjugation. The stability of alkene is directly proportional to the number of hyperconjugation structures, is directly proportional to number of alpha hydrogens. And the heat of hydrogenation, when I discussed about the heat of hydrogenation, these are all the things given. Electron donating groups is going to be increasing the stability, then electron withdrawing groups. And this is how these electron donating group, by using a positive mesomeric effect. So many things are there. And here it is electron withdrawing group, negative mesomeric effect. Okay. And the other examples, electron donating group could be anything here, electron withdrawing group could be anything here, electron donating group could be positive mesomeric effect, positive inductive effect, electron withdrawing group, negative mesomeric effect, negative inductive effect. Okay? Fine. And benzene and ethene. Benzene is highly reactive, highly stable, because of this aromaticity. Aromatic compound will have extraordinary stability. And alkene versus alkynes. And alkene, when a reagent is added, you are going to get a carbocation of A, so that it is a product. And alkyne you take, the electrophile is added, you are going to get a product intermediate B, so that it is a product. So if you compare the stability of B, compare the stability of A. A is more stable than B. That's what I want to say here. So the formation of the intermediate from the alkene is less activation energy is required. So the concept and the application for the NEET examination is super important. Activation energy for the carbocation formed from alkene is less, so that alkene undergo electrophilic addition reaction so easily. And stability of A is greater than B, electrophilic addition, alkene is going to be alkyne. So I mean to say here, activation energy of this alkene, okay, this is activation energy of this, this is your activation energy of this alkyne, C triple bond C. So this is less. Assertion reasoning type questions in the NEET examination, super important. Nandini, fine. Now this is very important. Never forget about this. Never forget about this. Clear? Now, so points to remember: when alkene are in a conjugation with alkynes, alkynes are more reactive. Super important towards electrophilic addition reaction. There will be a trap in the examination. I mean to say, okay, HBr. Okay, now I want to add this. Clear? Clear? If I want to discuss about this HBr, alkyne is going to be more reactive. So these are the golden tips that I wanted to give you. So these golden tips can help you a lot. And the ozonolysis of alkynes we already discussed. It's simple breaking, and carbon to carbon multiple bonds are broken, sigma bond is retained, so that you are going to get this dicarbonyl. Anus you are again, okay, but 2 ion you are going to get 2,3 dione, butane 2,3 dione, right? And you are going to see CH, triple bond CH, and O3, zinc, H2O. You are going to get glyoxal. You are going to get a glyoxal. Clear, beta? And in the absence of zinc, ozonolysis followed by hydrolysis produces acid that is called as acid ozonolysis. Okay. You want me to complete? Alkyne is already completed beta. Just 2-3 reactions bacha hai. ठीक है? Nandini, expecting you ask a doubt. So this is your alkyne, zinc and ozone H2O. You are going to get oxidative ozonolysis. Carboxylic group is formed because the bond that is here has to be broken here. Reductive में इतना carbon to carbon bond नहीं break होगा. ठीक है? And also polymerization, it can be linear polymerization or a cyclic polymerization. Linear polymerization, a linear chain form होना, and cyclic polymerization, rings form होना. Linear polymerization, this is acetylene, high temperature and pressure catalyst, you are going to get a polyacetylene. Propyne, linear polymerization, polypropylene, you got it. You take PET bottles ना, polypropylene का derivatives हैं. खाना आपका क्लास के बाद. ठीक है बेटा? Anuj, right? This is a linear polymerization. When you talk about a cyclic polymerization, acetylene is passed through red hot iron tube or copper tube. You are going to get cyclic polymerized to give rise a benzene. Aromatic rings are going to be formed. Are you getting or not? Fine. Okay. Now, terminal alkanes containing acidic hydrogen, test for terminal alkynes. This is an important concept that you can get it from the NEET examination. ठीक है? So I'll show you that. Test for terminal alkanes. You can undergo Tollens reagent. Tollens reagent means ammonical silver nitrate and ammonical cuprous chloride can also be used. Terminal alkanes gives rise a silver mirror with the Tollens reagent or black precipitate, or ammonical cuprous chloride is going to get a red brown precipitate. And you can see Tollens reagent give white precipitate, silver alkanyl. So this is the hydrogen responsible for reacting with the silver. Silver acetylide is formed. It's a white precipitate. Okay. अभी बिहार से, मध्य प्रदेश से बिहार कब पहुंच गया बेटा? Okay. Now you can see it gives a red precipitate with cuprous chloride, gives rise copper acetylide. So this is the hydrogen responsible for that, and it is given like this. Okay, so it is a red color precipitate. So appearance of this red color precipitate or white color precipitate is a test for alkyne. Now bacho, non-terminal alkanes do not react with Tollens reagent or ammonical cuprous chloride. So let me give you a tabular form to understand how the test can be done. You see, this is a very important table. So reagent, bromine water and cold alkaline KMnO4. Alkane, no reaction, no reaction. Alkene decolorizes, and you're going to get cold KMnO4. Pink color is disappear, you can say. Rather, you can say pink disappears. He also decolorizes, pink disappears. Got it? Any doubt? And if it is a terminal alkynes, so alkane, alkene and alkyne terminal. So Tollens reagent, ammonical cuprous chloride. Alkane do not react with, alkene also do not react with. While terminal alkanes, white precipitate of silver acetylide is formed, red precipitate of cuprous acetylide is formed. नोट्स लिखने का बहुत दिक्कत है, कोई प्रॉब्लम नहीं बेटा. Now I want to say NEET test series, unlimited success to your NEET. It is prepared for 11th standard ko, 12th standard ko and repeaters ko bhi alag alag kiya. So you all attempt this, and in the description box link is available. Click it and enter YouTube 30 off, so that you are going to get 30% discount. So prepare this NEET examination well. In the Telegram channel, notes will be given. You can do the best. And some questions are left. We'll do these questions later. So we'll have one-shot questions also, and that we're going to discuss in today's class. We had a very great discussion about alkanes, alkenes and alkynes without leaving any concept alone. So at the end of this today's session, I can guarantee you 12 marks, 3 questions from the NEET examination. 12 marks will be yours. Okay, hope you enjoyed this session, and please like this session and share with your friends. Subscribe to Infinity Learn NEET YouTube channel, so that we'll meet with the next session with arenes in one shot. So thank you very much. Love you. Bye bye. God bless you.